Hi, I am using video this week experimentally to try to comment on the program submissions for student homework module 4. So I'll just basically go through everyone who turned in their work. If there's something interesting, I'll try to point it out, and we'll see how it goes. So here we have a solution to the Minecraft pickaxe problem, which looks pretty good so far. I haven't finished the video, but I want to point out something. So let's.
For string item array.
Okay, so far so good. But did you see what happened there? So this is a great for each loop string item in array. That makes perfect sense because the input to stone pick this function or this method is a string array. So a for each loop to loop over that, great choice. This indentation is very non-standard. It's going to drive a decent size of the Java population kind of crazy. Notice how it differs from the indentation up here. So keeping the indentations consistent within a file is important, and generally keeping it consistent with the stylistic trends of the larger community is also important. So what that would mean is this. I know this is very subtle, but if you don't want to drive Java programmers crazy, pull that curly brace back one tab length.
This is basically just going to
Yeah.
go through each item. Each.
So the editor tried to put it here for you, and then you pushed it forward, which I guess is actually good. You are consistent within this kind of styling, but they really should both be back one. Notice that that's the styling for all of this code down here as well. So good to keep it consistent there. All right, let's move forward. I do like that you're at least being consistent within this kind of stylistic quirk, but those should also be back. All right. So then what do we end up having here? Basically, you loop over all of the arrays. You're checking, hey, is this item equal to sticks? Is it equal to cobblestone? Is it equal to wood? And you're incrementing various variables depending on what you find. And then at the end, you calculate how many pickaxes can be made and return that. All that's great. I'll point this out because I've seen this in a lot of student submissions. When you're inside of Code Wars, you don't have to do a main method. The reason is that main methods are to test your code. But Code Wars already has tests. There are all of these down here, these sample tests. So I guess there's nothing wrong with making additional tests, but you should definitely use the tests that are there first and only make additional ones if you need to. And if you really want to make additional tests, you can actually write them down here in this code block. So yeah, just keep that in mind. It'll save you a lot of time. These are already long videos, and the more time you save by not doing extra work like this, the more you can spend on, I don't know, finding clever new solutions, or you can go a little bit slower as you're writing this and run it more often and show that it works. There's a lot of ways you can use your time if you're not kind of duplicating the functionality.
Copy and paste that into there, and then do that. Oh, that is not right. That. I'm going to go ahead and just copy and paste this bit because I want to do 3 tests. I want to do one that creates one that creates.
Yeah, I mean, I like this. This is cool that you're pulling the exact examples and making them into tests. So you're testing your code well. So that's good. I'm gonna skip forward here. All right, so I see that you put all of those tests in, and then you're printing out what your method returns. So really quite good there. And what was the error you ran into?
And then we are going to test.
Okay, so you run into cannot find symbol cobblestones. Okay, all right. I see the problem myself. Let's see if you fix it.
Okay, that's an interesting one. Cobblestone count. That's fine.
There you go. Nice. Excellent. Anytime you see cannot find symbol, just means you're referencing a variable that doesn't exist. So symbol that hasn't been defined. Yeah, so you always start to look for misspellings or wrong variables if you see that.
Fine. Okay, try that. Perfect.
Yep, nice. Passed all the
So I'll
test.
do double
Okay, find next square.
root. Because
Okay, okay, I got.
that should be all.
All right, this this code is for me very hard to read, and it's because of the indentation. So this is another good reason to get those curly braces pulled back. It's okay if everything's consistent, but here it's starting to get actually incorrect. So those, if your curly brace is here, these need to go forward, because double and if and the SQ++, those are all inside the while loop. They need to line up. It's very hard. Like, people's eyes are not really looking for curly braces when they're reading code. We're looking at indentation depth. And so we need to be able to scan at a glance and know what's contained in what. And at first glance, it looks like square plus plus is inside of the while loop and these two are not. It takes me a second look to be like, oh, okay, they just did something funny with indentation here. So please, you have to tidy that indentation up as you're writing. Same down here. So a lot of this is very difficult to read. But let's see. Square. All right. So you are getting the square root of the input. Taking the floor of it and seeing if it, okay, I see. So just check, see if it's like a even number, basically. And then, while true, you add 1. You get the next square root of the now incremented variable. And if that next one is a whole number, you return that. Okay, nice. So yeah, you're looping up until you find another whole number square root, which means it's a perfect square, and you return it. Okay, very nice. And then otherwise, yeah, return -1. Okay, so that seems like a good, reasonable algorithm. Just hard to tell what the algorithm is at first glance.
Also, all we need to do now. Bars.
All right, once again, no need for this main method here because you have perfectly good tests down here.
As we go throughout the array. So first things first, let's take this out. We are going to go with different numbers out of a string, out of an array, pardon me, and then basically adding them together as we go throughout the array. So first things first, let's take this out. We are going to go ahead with making our array. So string result is equal to new string, and then this is going to have array dot length.
Okay, good start.
And we're gonna...
Good start here. Arrays coming in. You're making an array for your result at the same length as the existing array, and that makes sense because looking at the input here, it's input of length 4 and output also of length 4. It's just that the strings have changed. So the array itself is the same length. You just need to manipulate the strings inside. So good start there. Let me skip forward a little bit, see how you handle it. Okay, string builder, very nice. Anytime you're concatenating strings, it's going to be more efficient to use a string builder, so good choice there. Okay, now you're going to loop over the arrays. You have an extra semicolon here, but I'm sure you fix it. This is another case where you could just use a for each. You don't have to do a, well, who knows? Let me wait and see what you have here, but it's possible you could just get away with using a for each. Yeah, let's see. Okay, I think you have a slight misspelling here, but builder append. So I'm trying to figure out why you're doing this. Array sub I, replace, yeah, so you replace the spaces. Replace the spaces in the element of the array. But that's not really what the problem is about, I think. I mean, it sounds like it is running out of space, but if you just look at what the input and output is here, it's doing something kind of weirder, where the second one gets the first one concatenated onto it, and the third one gets the first and second ones concatenated on, and so on. But okay, so I don't think this is actually necessary, but all right, let's continue. Actually, let me see what you said when when you wrote that. Let's see if you justify it out loud.
Is basically apply a new value to your string as you go through the array. So we are going to do builder dot append array I dot replace. And basically, what this is going to do is this is going to replace a space with not space. So it'll cut the spaces throughout the function. So it'll take I and then it'll add half to it with the space removed, and it'll add no to it, just like it's happening here. So we're basically just replacing those spaces that would show up with no spaces.
Okay. Yeah. But if there's no spaces in, you don't need to do that. So I think that might not be necessary, but who knows? Maybe there's some test case where it is important. Let's see.
So after we go, after we do that, we want to actually put it back in the string. So result
driving me crazy.
Is equal to builder.
Looks good, except for the indentation and the main method you're about to make. Don't need that. Let me just skip ahead. Yeah, you're literally doing the exact same thing right here. You're probably doing this because I asked you to do this on previous modules before the Code Wars ones, but in Code Wars you don't have to do this. Okay, now you're running into the fact that you have the double semicolon there. And looks like you found it. All right, cool. Yeah, good. This is great. Okay, so this is another batch of solutions. Looks like we're starting with next perfect square.
Long root is equal to our, I'll find the for just a second, long. We're going to use a function called math.sqrt and list as a square what we get. So we're going to do our input, which is going to be square. The reason for this long change is because we can only accept, we're only get a state double out of math.square. Oops, sorry. So for the next part, we need this needs to equal r if not.
All right, so I'm already seeing some indentation quirks right here. So that long needs to either come back or the if statement needs to go forward. These need to line up. Other than that, looks like you're taking your square root. Now you're squaring it again, which is pretty interesting. Okay, yeah, so that effectively does the same thing as we saw in the last video, but in an interestingly different way. So you first square root it, you cast it to a long, which is the same as flooring, so it's gonna like get rid of any things after the decimal point, and then you square it again and check to see if it's equal, and if it is equal, then it must have been a perfect square because there was nothing after the decimal point. If it's not equal, then it wasn't a perfect square. So this is just a clever way to check for perfect squareness. That's nice. Then you calculate the next square by adding 1 to root and adding 1 to root again and then squaring that. Okay. You could pull this root plus 1 out into a variable and then just square that same variable and not have to repeat root plus 1 twice, but it's fine. All right, let's keep going.
We can return
Yeah, return -1.
So integers of stone, set to 0, we need an integer, those are the text we're going to st is equal to.
All right, I'm skipping ahead here because it seems reasonable so far.
And this function takes in a string, which we have called materials, make sure that string is equal to whatever we give it. So we will start off with sticks, because that's what.
All right.
And just like the last one, we need. So.
Yeah, so we end up with something very similar. Nice indentation. This is beautiful. For each loop. Yep, and you were just manipulating our variables based on what we find in the array. All great. Okay, so this is actually a great solution to like juxtapose with the previous one. I see what you're doing here. You do need to say plus equals, but I'm pretty sure you're going to fix that in a moment. But this concatenating onto a string does the same thing as using string builder, but this is slower ways that are not going to be really perceptible on a problem of this size. But if you were looping over like a million strings and concatenating onto some other string, that would start to be a lot slower than using a string builder. So good practice to use a string builder. It's not going to bite you in this problem, but I just am going to point that out as I'm not going to take off points. I'm just pointing it out as an area of improvement.
I'm going to use a function that is seen before, which is replace all, and we want to replace all. And replace all takes two parameters. The first one is the one we're going to replace with the second one, separated by a comma. The second one we're going to have no spaces. This one is going to take all white spaces.
All right. Yeah, this is interesting. Interesting for two reasons, because I realized the last solution used replace and not replace all, so I wonder if there's actually a small bug in the previous solution. Not a big deal, but replace and replace all are not quite the same. Replace all does all instances of the first thing. That's interesting point number one. Interesting point number two is this is a regular expression. And I think you said the right things while you were writing this to convince me that you understand it. But let me listen again, because I heard you say that this replaces all spaces. I'm not sure I heard what the plus means, but let me listen again.
Second one, separated by a comma. Second one, we're going to have no spaces. This one is going to take all white spaces out of the equation. Yeah.
I think I wouldn't take off points for this, but I'll just note that I'm not convinced you know what the plus is. Or the slashes. But you are right, like what you said is correct. Like if you're looking at the bird's eye view of this, yeah, it's going to replace all white spaces. /s means white space. Plus means one or more of those. So if there were like 5 white spaces in a row, it would get rid of all of those. And then the // having 2 slashes, the first slash is necessary to escape the second slash, because slash is a special character inside of a Java string. So ends up with this kind of bizarre looking syntax, 2 slashes, an S and a plus. Looks very mysterious to people who've never seen regular expressions before. But each character there is actually doing something important. And so when you use a new thing like that I'm pretty sure you haven't seen before, generally speaking, you're going to need to prove to me that you understand it, because I know that it was not a big part of your Java 1 curriculum, which means that you just found it somewhere, which is fine. That is how we learn Java, is we find stuff somewhere. But when you find code somewhere, try to make sure that you understand every character in it. Don't just like copy it and like assume things about it, because there's a lot to be learned from the details. So again, I won't take off points there, because it does seem like you at least understand what's happening here. So that's fine.
And after that, we need to have a return of results of I that is yet. So our replace all is now going to be renamed into each instance of the result I.
So this is all right. There are 2 bugs in this code right now. One is you're not actually concatenating here with a plus, and one is that you misspelled concat right here. This is the kind of thing that if you run your code more often, you'll avoid. Like if you had maybe done a system out print line right here, just to make sure concat is looking the way it's supposed to look, then you would have caught this plus equals error already. But because you didn't do that and you're moving on to just writing the rest of the code, the bugs are piling up. And that can make things difficult. In fact, you're on the last problem here, I think, right? And this one takes you a long time. And it does look like there's a pretty big debugging session in here. So just having kind of like good code hygiene habits, running your code often will actually save you more time than it costs you. It's been my experience. I just noticed a third bug. You also have misspelled length right here. Okay, I'm skipping this because you don't need to do that. Don't need a main method for this. Yeah, okay. It is good that you're writing a test, but I think that's the exact test from below. We've got to wait for it to buffer. Okay, yeah, so you're even debugging down inside your main right now. All right, so you got this bug, misspelling length. All right, got that one. Indentation is wrong here.
lower letters over array difference from index 1 as
Yeah.
camel case, upper's case.
Right, so now you're running into basically it's not concatenating. It's expecting something concatenated, but it's getting a non-concatenated thing. So I'm curious if you'll find the plus equals bug now.
Okay, so these are all different. So we're stepping around in program. We have 14 minutes left. So you're taking in a string array dot length and not sorry, we're making a new string with the array dot length and calling it result of a string result. We're making a string of concatenating.
I love what you're doing. This is awesome. Actually, so I love seeing a good debugging story. This is like it's like a needle in a haystack, right? I mean, I saw it immediately, but only because like, you know, I'm looking for that kind of thing. And I do miss stuff like this as well. So I love how you're like, okay, I fixed all my syntax errors. There's something wrong with the logic, and you're reading your own code line by line. That is perfect. That's fantastic. I'm very curious to see if you'll catch it when you get here.
That equals nothing. For int I is less than the array dot length increment by I. We need to
Nice.
make sure to do that.
Nice.
Array dot I, we replace all blank spaces with nothing. We return the result of.
I guess it's okay to keep reading, but if you found something that's definitely wrong, you should run your code again immediately. Because otherwise you might continue going down and then have a temptation to fix something else. And you really should be like kind of like a scientist when you run your code. Like make one change, see what it does. Does it do what you expected it to do? Make another change and repeat. If you start making multiple changes to your code at once and then run it, run the risk of introducing, you know, strange behavior. Obviously, if it's just simple syntax errors, you can fix as many of those as you want. But this is a kind of a major logic change. You know, you should now see what the changed behavior is. So code is one thing, code's behavior is another, but you always want to have an understanding of both, which means you need to be running code often.
Running array dot length from our concatenate and return the result.
I'm going to skip ahead.
Array called input and putting it into state.
All right,
Result for each result.
skipping.
That,
All right, yeah, and that worked.
when
They
you're
made it work.
manually splitting or afterwards. In my last video.
All right, yeah, nice. Okay, let's check out student number 3 here.
And I'm gonna start with this one. So we get an array,
All right, starting with running out of space. I like it, like the variety here we're seeing.
and I need to concatenate and then return a new array.
Okay, making this a result variable.
Cycle through the array. All right, I need a variable to hold each word, so I'm gonna make a new string.
Okay.
A word instead of equal to a blank string, and we're gonna.
All right, so same issue here. String builder would be faster, more efficient. Just a good thing to keep in mind.
Say word, word plus equals array sub I. That's gonna set. That's gonna concatenate array sub I onto word, and then.
Mm-hmm. Yep. Awesome. Also, your indentation is fantastic. You don't necessarily need a space at the top of your for loop, but nothing wrong with it. And sometimes I do that if I'm like not sure if maybe I need to put something. It's like a personal reminder that maybe something needs to go before this line, and I haven't decided yet. So maybe you're doing the same thing there.
Result sub I is equal to word, and then we're gonna return the result.
Yeah. I mean, that should do it. That should do it. That's probably like the fewest, you know, characters solution that we've seen so far. But even though it is shorter, it is arguably less good because it uses string concatenation, so it will run slower. And if it was a large input array, then it would run significantly slower. So you could optimize this by using string builder. All right, I'm gonna skip ahead to find the next perfect square.
We're gonna find the next perfect square. So perfect square is when the square root is of number is an integer. So I'm gonna do.
I know it's subtle, but I love what just happened there.
So
Let me show again.
find the next perfect square. So perfect square is when the square root is of number is an integer.
So you pressed enter. The editor puts you right here, but that was different from your return 0, and then you press tab and made it consistent. Awesome, because that's the point. Is it just needs to be consistent within the code block. Could have also pulled the return 0 back. That would have been fine. But you pushed your current line forward, which is also great.
So, I'm going to do, I'll call it long, yeah, instead of int. So equals 0. And then result equals, we're going to take the number they give me, find square root, add 1, square that, that's going to give us the next part of square. It's the next perfect square. So math dot.
Yeah, so that explanation there is really good. Let me listen to that again.
We're going to take the number they give me, find square root, add 1, square that, that's going to give us the next perfect square.
Okay, yes. Take the number they give you, square root that, add 1, square that, and that gives you next perfect square. So that English description of this algorithm tells me that you're going to use the same math trick from the previous one, but I think that that explanation tells me that you're understanding the code. And just to be clear, the previous student, I think maybe you also understood, but it just wasn't clear to me necessarily. So just know that I'm listening to your out loud narratives when you're writing code to try to get a hint of like the depth of your understanding of what you're doing and why.
So math dot square root of square, and then add 1, and then I'm going to multiply that by itself.
Okay, wait, hold up. All right, so that should be at times. I'm sure you're going to fix that in a second. A couple other things I'm a little confused about. One is if you set result to 0 and then immediately set result to something else, that can always be simplified. Like you can just take this part and move it up and just set result to be that immediately. No need to make it be 0 first. So that's just one way you could like shorten up your code a little bit. And then the other one is there's still some repetition here. Math square root square plus 1. You repeat that twice. If you take that part and store that into a variable, then you don't have to repeat that long mathematical expression twice. It'll be shorter and it'll be easier to read. And it'll be easier to change if you decide, oh, it wasn't quite right. It needed to be +2 or +3 or something. I know that doesn't make sense in this problem, but coders have a motto, and it's don't repeat yourself. DRY. It's so pervasive in coding culture. We call it DRY. It's just an acronym. Don't repeat yourself. And so there are small ways that you can start using that kind of code hygiene principle early on, even in short pieces of code like this. So some minor repetition here. Just like indentation drives programmers crazy, so does repetition. So just thought, not taking off points for that. This is a great solution. Just some advice.
Also, math dot square. This produces a double, so I'm going to cast that to a long because our result is long. I didn't multiply by itself. I added it by itself.
Okay.
That's a double.
I think that's probably gonna work.
Oh, okay. I guess it's the side goes. No. All right.
All right, this is interesting and totally fine. You're allowed to have Eclipse on the side to like, run your code and do some side calculations.
All right, pass 2.
Yeah. So what did you have to do? This ends up being kind of messy, right? Because you cast the square root part to a long. And then you multiply, and then you have to cast it to a long again? I feel like you could probably get away with not having this outer cast, at least. And then if you did what I mentioned earlier and pulled this out into a variable, then this line would start to look a lot less noisy. Even if you did still need to have 2 casts, it would at least not be like long, and then like a bunch of parentheses all kind of crowded together. It's starting to get hard to read what the actual math is because of the extra casting.
Test failed 1. Test 3 expected -1. So here it says, if the argument itself is not a perfect square, then return -1. Okay.
So this is actually great. This is, by the way, I want to point out that what's happening here is fantastic. I think a lot of you have a temptation to think that like a perfect solution means you write the code and you've got everything right and you press run and everything is green. But that is only feasible if it's something you've like practiced and trained on. Any real life problem that you run across, you're going to have to solve it bit by bit. This actually does solve a lot of the problem. It just hasn't solved this part right here. If the argument is not a perfect square, return -1. So you solve the problem for some of the possible inputs, and now the tests are failing on other possible inputs, so you're going to evolve the code to handle those new cases. That's incredibly authentic and legitimate, and in fact, I want to see that because that shows me you're like the actual evolution of your problem-solving process. So I would not take off points for this. In fact, I'm tempted to give bonus points because of how authentically you are actually solving the problem right here in front of me. So kudos for what's going on right here.
So we've got to check if the number they're passing in is a perfect square. So let's see. If we're going to do find square root again, and we're going to check and see if that's an integer. And if it is, that means it's a perfect square. So if math.square equal what am I doing? Again, math.square. So I'm going to cast this to a long. And that'll make it an integer. And I'm comparing the result, which is a double. If it's the same as an integer, then we're going to execute this code.
Okay. This makes sense. Yeah, so you're using the long, casting to a long to get rid of everything after the decimal, and then if it's equal to whatever the double value of that is, then it must be a square. That's true. That's slightly incorrect to say that it's becoming an integer because it's actually becoming a long. But I think what you meant in this context is that it's becoming a whole number. And in fact, if you were talking to a mathematician, they would say integer because that just has a generic meaning no matter how big the number is. It's just a quirk of computer science that we divide numbers into ints and longs because of storage space issues. So you spoke correctly as a mathematician, but maybe Java programmers would say, aha, what you meant to say there was a long. How did your indentation get messed up here? Was it just a copy-paste issue? Okay, I see. Yeah, so you had these beautiful indentation before and then copy-pasted it in, but I'm sure you're about to fix it, so.
Else.
Ah!
Return.
No! The indentation was so good. But yeah, the copy-paste funked something up right here, and then this else needs to line up with this if. Ah, beautiful. That was beautiful. By the way, those of you who don't want to keep your indentation like tidy as you go, there are hotkeys to do it. Just a single flick of the wrist and it'll tidy everything. So good use of that flick of the wrist here.
There we go.
Nice. Okay.
All right.
All right, and then stone pickaxe, and this one I think is the easier one, so I'm just gonna kind of scooch forward here. Yeah, go through the array.
Array sub I equal start stones.
Can be dangerous to compare strings with equal. This is probably something y'all learned in Java 1. You really should use dot equal here. So I'm curious if you're going to run into a bug.
And I'll initialize all this to 0. So if array sub I if array sub I equals 4.
Okay. Logic looks good. Tiny indentation issue right here. Yeah, the big issue I'm seeing is the equal. So I'm very curious if this is going to actually work. So skipping ahead. Oh, now this is interesting. Okay, so instead of doing like a mathematical trick here, you're going to actually loop over stones. Okay.
Stones is greater than or equal to 3, and sticks are greater than or equal to 2. Result plus. So we're gonna make a pickaxe or whatever it is, and when we make that, we're gonna do stones minus 3 sticks -2.
Oh yeah, I like this. This is, I know that in the previous solutions, the like mathematical trick that we saw is shorter. It's also faster, but this to me is much clearer and should make a lot more sense to anyone who actually plays Minecraft. The idea is you have some amount of ingredients and then you start taking away the appropriate amounts of each ingredient and incrementing up the number of things you've created with that ingredient. So this is, yeah, I mean, I feel like this is more intuitive and perhaps clearer, at least to me. All right, does it work? All right, it does work. It does work, but my recommendation is you should look up Java strings and equality comparisons to know when this kind of thing is safe or not. Student number 4.
So I'll go over here and it wants me to create an array, so I'll import Java util array, so import java.util.arrays, and hop over here, and then create my variable, so go int n equals array.length.
Okay. So one thing is there's a semicolon missing. That's just a syntax error. 2, I didn't catch why you're importing Java util arrays. It might have been clear if the very next thing you did used Java util arrays, but array.length is just a normal Java thing, so I'm still puzzled by that. I'll just point that out.
Over here, I'll print string result equals new string and close this off. And then I'll create a new string, so string builder string equals, oh, forget my parentheses, now I close it off, and string dot, now that made it so that it reads this string but then has no spaces in between, so I'll use append open brace array I, close this off, and then I'll go over here and I want it to return my result. Alright, I haven't created my results yet, my result string yet, so result I, close this off, go over here, equals, and new string, Control C, Control V, that'll be to the string. Open bracket, close bracket, close it off. Now I want it to return my results. Control V, Control S.
Okay. Yeah, so this up here was not necessary, so that's a clue to me. That was a clue early on that I think you might have found a solution somewhere and kind of memorized it rather than like solving it yourself. I could be wrong, but whenever there's a line that doesn't need to be there, correct me if I'm wrong. If you put this line in for some important reason, let me know. Send me a Canvas message. But generally, I didn't feel that you totally understood what's going on here. I'll probably take off some points, but I won't say in the video exactly how many. I need to think about it. But yeah, let's see if you see how you do with debugging it.
And one, forgot to close this off. Control S, see if I have any more errors. For int I is less than, and string append.
So you can find this error more quickly if you read what it's saying. It says variable I might not have been initialized. And it's telling you, it's pointing to this I right here in the I less than n. So if it's saying, hey, that I right there might not have been initialized, you just need to scan a little bit earlier and see where should it have been initialized. And it should be right there. Int I needs some value equals 0 is what you probably are meaning to say. But it can be tempting to just see an error and then just kind of start looking in the general vicinity, and that is a good technique sometimes. But it will speed you up if you actually read it and try to think about what it's saying. Because a lot of these errors you're going to see again and again. The same kinds of errors tend to come up often in programming. So, it pays to try to like learn what the computer is telling you, because it'll just make you more efficient at debugging in the future. I'm going to skip ahead and see if you find it.
And string.
Okay, there, you're reading it now. I like it. Ah, and you found it.
Oh,
I think.
that's okay. I forgot that you
Yeah,
said-
nice.
Cool. And then
Nice
let's
job.
do-
Okay, perfect square.
Find the next square. So if it's a perfect square, it'll pass on to the next one. And if it's not a perfect square, then it'll return that -1. So I'll go over here, then go since it's long, I'll go long, and I'll call this root from a root dot square root
Okay.
SQ open break plus plus, and then I'll return the root times.
Yeah. Okay. This is another classic example of you are explaining what code you're writing, but you're not explaining to me why you're writing it. So that's the kind of thing I'm usually listening for, is do you understand why you're writing the code? If all I hear is what's, then I get the sense that you looked at a solution, maybe memorized it or understood it at the surface level, and then you're like writing it in. Or worst case scenario, you're actually like, looking at code off screen. I don't think that's what's happening here, but either way, whether you're looking at it off screen or you just kind of like memorized the lines, but not the like rationale behind it, then it tells me that you're not like really deeply understanding it. And then there's some other issues here, like you have some indentation problems, and you're missing a semicolon right here, so you have multiple bugs in your code at once. That's the kind of thing that'll, if you run your code more often, you can avoid. And you're using this clever math trick that from earlier, the fact that that you can square root something, add 1 to it, and then square that again to find the next perfect square. Like, that's, to me, that's mind-blowing. So you gotta justify that works, and that's what your code is doing.
Root. And then else open brace, close brace, go return.
Yeah, so you don't actually need to say I guess, I mean, if you want to, you can say else open brace, close brace. That's fine. But it would also be totally fine to be silent during that while you're typing else open brace, close brace, because I'm listening not for like, are you describing what you're writing? I'm listening for evidence that you understand why you're writing what you're writing. So just telling me the syntax that you're typing in doesn't actually tell me that you understand why you're typing that syntax in. Return -1. Yep. Okay. Right. Okay. Yes, that seems correct. All right. So now you end up having to do some debugging. I'm gonna skip ahead. Okay. It looks like you got it. All right. So now we're at the stone pickaxe one.
Go over here, switch over to instructions. Let me see how much time I have left. 9 minutes. So it wants me to create a sorter. I should get that in Minecraft, but I'll use Java. So based off Minecraft, wants me within the array would be a series of strings that will extract with the strings with the exact names of the material list below. A single pickaxe is made of 3 cobblestones and 2 sticks. Check if your given array contains enough sticks and cobblestones to
All right.
take out the -1 as well. So I'll create my variable, so int called stick equals 0. Now in my variables down, I'm gonna create a sort. So for for string, I'll call them materials instead of array.
Okay.
Material plus control C.
All right. So yeah, I'm seeing some dot equals here. That's good. I mentioned that in the previous one. That's better than just doing double equals. Again, I do like how you went through the problem, kind of like explain what you're doing. Shows that you actually like read the problem and understand what's going on here. But again, yeah, I'm hearing a lot of like description of what you're writing and not justifications of why you're choosing to do that. Running your code more often can also show me that you understand what your code would do. Those are 2 ways that you can demonstrate that you're like understanding what's going on. but I'm guessing you're going to get the code right here. Yeah, it looks all good. Okay, and then using this mathematical trick to see how many times you can take 3 out of cobblestones and 2 out of sticks. That works. Although I think I still prefer the for loop idea. But yeah, okay, so that looks good. So I'd probably take off a few points on these just for lack of justification about why. So please try in the future to describe to me not just what the code is, because I can see that, but why you decided to write that code. All right, this is student number 5 here. 10-minute solution for these 3 problems. So I'm very curious how what these solutions will be. Starting with running out of space.
The module for problem is going to be running out of space. So essentially, we are combining the strings in this array, starting with the beginning and then slowly adding on the following arrays or following strings.
Yeah, so that's a very good English description of what is described here with this input and output. Nice.
So I'm going to make a new string array. We'll call it decreasing. This new string, we'll set it to array.length. And we'll do now is I'm going to make a for loop. 0 I is less than decreasing.length I plus plus. And so I'm going to be iterating through decreasing and then assigning each element a blank string.
Huh. Iterating through decreasing and assigning each one a blank string. Okay, interesting. Curious why a blank string, but maybe I'll change that in a moment.
Actually, I will do a quick test here. But the reason I'm doing this, the normal type for loop, is because before I tried out.
Yes.
I tried doing it with the shorthand.
Yes.
Arrays,
I love what you're about to do.
Null value that gets assigned.
Yes. Okay, this is fantastic. This is the first example I've seen where you're basically solving the problem right in front of me. This is fantastic. Right. At the end of the day, do you want a dot in here? No, but you know that, and you're just running it now to see that the code you do have corresponds to your expectations of it. Like, you have grander plans for this this decreasing. I think I can. That's what I'm assuming right now. We'll see in a moment. But you're testing literally the whole code right now just with this simple print line. If you had made some small error, like left off this semicolon or misspelled something, or if there's some error up in the for loop, you would have uncovered it by this test right here. So good. Love it.
When you initialize an array like this, so as you can see, we have just all periods here. And I'm going to set that back to a blank string. Get rid of that. Actually, I will keep that for later. And then we're going to make another for loop now. So int I equals 0, I is less than array.length, I plus plus. To see what we're working with. Okay.
All right. Once again, yeah, super good. Okay, so first loop initializes the decreasing array to a bunch of empty strings. And then here you are basically just testing what's in your input array, looping over input and printing it out. So that's awesome. Oh, and then you're going to do an inner for loop. Okay, so for every thing in your input, you're going to loop over the rest of your input. Oh, okay, I see what you're doing. Yeah, you're going to loop from 0 up to I on your inner loop and start concatenating. Cool. All right, I like it.
I equals j plus plus. Now what will happen is we're going to set decreasing at I plus equals array j, and get rid of that down here, and instead we'll do decrease.
Yeah, so awesome. A lot of good stuff here. So you're concatenating into those empty strings that you just made, concatenating on parts of the input array, and then just to double check, you're going to print out decreasing after the concatenation just to make sure your algorithm is shaping up the way you want it to.
So now it should slowly combine each of the strings at each new element. So let's test it out. Yep, so first when I and j are equal to 0, so Kevin, and then when it sets decreasing, test it one more time. And
Yeah.
We'll go this method here.
Yeah, that was flawless. That was actually better than flawless. not only would I not take off points, I'm tempted to give you bonus points because it's the first time I've seen like a really good step-by-step solve it in front of me with output. You're running your code often. Super good. Great solution there. I understood your logic step by step there. I got the sense it wasn't just about you putting the code together, it was about you actually showing your problem solving process. So yeah, really good. All right, so let's see, perfect square.
Math. We make a new long called result. And we make our if statement. So if math dot square root of square mod 1 is not equal to 0, then we'll return a negative 1. That should take care of that. Now this should be...
Okay, wait, maybe I skipped over it. But yeah, I mean, this is another way to check to see if something is a whole number. It's just one we haven't seen before. Let me back up. Just want to make sure you gave a justification for why mod 1.
Math. We make a new long called result. And we're going to make our if statement. So if math dot square root of square.
All right, maybe I missed it.
Here, define next square. So to start off, I'm going to import return to decrease. Also green. Submit. Define the next square. So to start off, I'm going to import math. We make a new long called result. And we're going to make our if statement. So if...
Yeah, okay, so I guess I'm not hearing it. Yeah, so you do put an if statement in, and it is a correct thing to do, but I would have liked to hear you connect the dots between doing that and I guess you're implementing this paragraph here if it's not a perfect square. So telling me that that's what this if statement is for would have been nice. And then the mod 1 trick is another like magical math thing that would be nice to hear you unpack that in English.
Math dot. Then return a negative 1. That should take care of that. Now this should be...
Yeah, so like that takes care of what? I would like to hear you say what it takes care of. I think you probably know, but depending on how the rest of this one shapes up, I might not take off points for that, but just as a piece of advice, that's the kind of explanation I'm listening for. So what does it take care of?
So we're going to set result equal to math.round and then math.square root. And the reason we're doing that is because just doing math.square root by itself sets it as a double, even if it is a perfect square. So math.round will convert it to a long. And then we're going to add 1 because we're looking for the next perfect square. So let's go and print this. So results.
Okay, I like the printout right there. Maybe would have been nice to hear more about why square rooting, rounding, then adding 1 gives the next perfect square. I mean, you did say that, and I think you understand what you're doing, but showing that on a few inputs would have been nice to kind of reveal some of the magic behind the math.
Okay, so yep, 12 times 12 is going to be 144. So that is what we're looking for. Well, not 12 exactly, but I'm going to be saying result times equals itself should result in the integer or the long that we're looking for.
Yes, so this is a great technique, right? Add a line, then move your print statement down to see how your result is shaping up. That was really nice. Yeah, and so now you're seeing that you're returning the right things, and so it's just one more step, which is to actually return result, which I'm sure you're about to do.
Yep, so 144, and it's looking for 144, 676, it's looking for 676. So let's go and set return to result.
Nice. Nice. All green. Okay, I'm going to go ahead and skip ahead.
Load and 6 to determine how many picks we can end up with. Copy that.
Woohoo.
So this is 6.
So for those of you looking for ways to like speed up, that was a nice trick. Anytime you need to define several variables, just define one and then copy paste the rest. It goes by really fast. Here, let's see.
Combo 0. Copy that.
Boop. And then change the names, obviously.
So this is 6. Set this to not load, picks. And then now we're going to make a for loop. And we can set this to string.
Okay.
If
For each loop there, good.
A equals Uh,
All right, so again, probably should be wary of this kind of string comparison, although it does work here.
6 plus plus. Plus, yeah, wood can be treated as 6, typically for 6 for 1 wood.
Yep. All right. And I like that you're justifying that, tying it back to the problem statement. It's good. All right. Printing out.
Double. Plus 6.
Yeah, this is another good trick to remember that if you want to print out, you want to see the value of multiple variables at once, just concatenate them together in a single print line. Cobble and sticks are what matter here, and you want to see what they're equal to after this for loop, because that's important. If they're equal to the wrong thing, then there's a bug up in here somewhere. So you should never assume that you've written the code correctly, and that's why it's so nice to double check your assumptions, double check your own code by doing stuff like this. So this is really good. I would highly recommend everyone start doing this. And look, it doesn't take up that much time. This is actually the shortest solution so far, but it has the most testing so far.
So that. Oh, forgot my semicolon. Okay, so we have 6 and 4, which should result in 2 picks. Let's do it down here.
Yeah. So even though the problem's not done yet, you're basically saying, am I on the right track? So you saw that there's 6 and 4, and that should yield 2 picks, and that is indeed what should come out here. So it means that cobble and sticks can be used to calculate the final answer here, which is 2. And so that should motivate the next line that you're going to write, which I think is coming up.
Here's going to be 1 pig, 1 pig. Okay. What I'm going to do now, so what I'll do now is I'm going to set picks equal to math.min to determine which of these is going to be the smallest number. So 1 6 by 2, and we'll let that out.
Mm-hmm. Yep.
There we go. Okay, so picks is 2 in this case, which is correct. 1 in this case, that's correct. 1 in this case, 0, 3 in this case. Yep, so everything's looking good.
Yes, everything's looking good, meaning this variable has the correct solution in it, so now last step is just to return it.
Return to picks. That's it.
Yes, that was fantastic. All of these were great. Yeah, so I think I would give this full credit, even though that I could have used a little bit more explanation at 1 or 2 points in the perfect squares. But just as advice to anyone who's watching, just remember that this is not only great coding practice to print things out and check your assumptions, it's also going to save you time. You're going to have fewer bugs, and it will make sure, for the purposes of this class, that you kind of halt on a line and explain it, because you're going to run it and try to make sense of the output of that line in relation to whatever the problem is looking for. So it'll help make sure that you don't come across as just having memorized a solution, or worse, copying an off-screen solution. It shows me your process a lot better. So great job here. Yeah, nice. All right, this is student number 6. Whoa, just under 8 minutes here. So this is the student who's going for the speedrun world record of the class so far.
You are going through some code words problems again.
All right.
So Kevin is noticing his space is run out. Write a function that removes the spaces from the values and returns an array showing the space.
All right, good.
I have no space would produce. I have no nine.
All right.
Oh, I don't think.
Yep, good overview of the problem there. Took about 45 seconds. I'm just very curious how you're spending your time here, given that it's such a quick run. All right, here we go. Let's see how spacey turns out.
Int I is equal to, we're going to start at 1 since index 0 doesn't ever change. I is less than array.length. And then we're going to increment up I.
Start at the first, or these, I guess the second element, because the first one doesn't change. Oh, okay, so you're about to change this array in place. So all these solutions we've seen so far construct a new array and start putting these larger strings into it. This is the first one that's actually just going to take the first one and start altering, manipulating those strings. Interesting. All right, minor nitpick here is the indentation.
And for this, oops, array I, because again, we don't need to touch index 0. We're going to do array I minus 1. So we're going to look at the index before and add it to array I.
by doing this, we don't have to initialize any new arrays. And then we can just come in, return, array.
Yeah. All right. Yeah, that is good. Yeah, this is when I solved this problem the first time a few years ago, I think this is essentially my solution. So you start iterating through. So think of it as you're iterating on this one. You start on this one and you add the previous one to it. So it becomes I have. And then you go to the next one and you add the previous one to it, which is I have now because you changed it on the previous loop. So then this one becomes I have no. And then you go to the next one and add the previous one to it. So that's adding I have no to space. And then you end up with this. So yeah, very clever. Yeah, nice.
And submit that.
Okay.
Those are pretty large perfect squares. But what about the next one?
All right, skipping
Perfect square
to
after the one pass is a print. Every event is also an integer, or null, depending on your language. You may assume the arg. So for this, first things first that we're going to want to do, let's make a long root. We're going to typecast on math.square root, get the square root of that square. And then from that, we can check the root, typecast again, math.pow, root 2.
this. I gotta point this out. This is great. This is another way you can show me that you understand something by selecting a really good variable name. Like, you could say, now I'm about to check the root. Or, yeah, make a variable called checkRoot, and then I know. That makes it very clear to people who are reading your code why some variable exists.
And then we can make one more, because we can assume that...
Wait, but why does that check the root? MathPow. Oh. Okay, so you square root it, and then you square it again. Okay, so maybe you're about to use this to check the root.
That once we found our first perfect square, and then you give me square root of that, find the root that I have here, the next perfect square is going to be root plus 1. We'll do check square, typecast again, math.pow, root plus 1 to the power of 2. So it's the same thing we're doing over and over again. Then we're going to go ahead and use our ternary operator. Just check root, and make sure that that is equal to square, because if it's not, then it's not a perfect square. So
Okay.
if it is,
Okay, so check root, check that against square. All right, and if it is, then this... I don't know if check square is the best name for this variable, but it's like the next potential perfect square up.
then check square.
So that's...
we return -1.
Yeah, I mean, ternary is the quickest way to sort of tighten up this code. So yeah, nice. Yep. So you do this. This is the same logic we've seen in some of the previous ones. It's just shorter because of the ternary. Also, you don't have to use math.pow. You could use root times root. That's an option. Might save you some typecasting there.
Let me just make sure I have everything here. Oops. So check root. If that's equal to square, so when we square a root, then we know it's a perfect square, and then it's going to return our check square, which is root plus 1. So it's like, again, it's just adding 1 to the root, and then squaring it. And then if it's not, it's going to return -1.
Yeah, so I mean, this is great. It's, you know, triggers my same complaint from some of the previous solutions. I've decided not to take off points for this, but if you want to clarify this a little bit more, the fact that just the mathematical trick of taking a number, square rooting it, chopping off the decimal, adding 1, and then squaring again, the fact that that gives you the next perfect square up, I think is not immediately clear. So some amount of mathematical argumentation or explanation for why that works would be nice.
Perfect.
All right.
No based off Minecraft. Hopefully you at least know the game. Sorry, a lot of stone pickaxes though, as they break and jump immediately.
All right,
Pickaxe is made of 3 copper, 4 sticks.
Skipping to the code.
Var item in array. So var it infers the type of data based on the data that's in there.
I haven't seen var in a long time. Actually, var is a very new thing in Java. But yeah, so you can avoid having to write the type of something by using var. I don't know why you'd want to, though. I mean, it's very clearly a string array. No need to infer. I guess it's slightly shorter than writing out the word string. Not sure how I feel about var. I think string is slightly better here. Again, not taking off points, but I just think Java has types in it for a reason, and that reason is usually to catch errors if you misuse one kind of data for another. like compile errors are usually type errors in Java, and they save you. They save you trouble and time because they catch your logical mistakes. So anytime you're using var, might get less less safety, but it's okay, and it's kind of nice to see something like this. We haven't seen it yet in this series of videos, so good thing for other students to see.
You can't use that in all scenarios, but in this one it is appropriate. So as we do that, I want to use a switch item, and then in case, what was it, cobblestone, we want to cobble count plus plus.
Whoa. I have never seen this syntax. What does this do? Is this some like brand new Java switch statement syntax? The fact that you can do like an arrow here is new to me. Hold on, I'm gonna look this up. Java switch statement arrow? Modern Java. Yes, this is new. All right, I've been programming in Java for 20 years, but you know, sometimes they introduce new syntax that surprises me. I've seen this in other languages. I just didn't know like you could do this in Java. So it looks like it's new as of Java 14. Yeah, this is the old way that I would recognize. But yeah, new way is you can just say case arrow and then something to call after that. All right, cool. Yeah, so var and this arrow are both parts of like the new Java. Java's always evolving and, you know, incorporating things from other languages, and so these are two examples of that.
And we'll do another case for sticks, and that will also implement our stick count. And then now we're just going to do the same thing for wood, because they said 1 wood is equal to 4 sticks. So we will do stick count plus equals 4. So anytime there's wood, it'll just add 4 to our stick count.
All right.
3 cobblestone and 2 sticks. So we know that we can make. We know that we can create a pickaxe. So let's come outside of our loop here and return. So we want the minimum number of those to tell us exactly how many we can make. Let's do math.min, cobble count divided by 3, and to tell us exactly how many pickaxes we need.
Okay, cool. Yep, that works. Yep, and then just minor nitpick on the indentation here. And then my overall, like if you want a piece of advice, you're already so far under the time limit that you could definitely afford to do a little bit more running of your code and showing me what different variables do at different times. Basically more print lines as you're like evolving your code. But I definitely commend you on the use of modern Java syntax. That's really great. I'm sure you came across it either in another class or you read it in some of the solutions to these problems, which is awesome. I mean, that is the way that you learn Java after you're done with school, is entirely by reading other people's Java code, coming across interesting things. So I'm glad that you're picking up some new stuff. You also have a for each loop here, which is not as new as some of these other things, but also a newer thing in Java. Didn't used to be there back when it was invented. So yeah, for each loop, var, an arrow on the switches. Just got to be careful on a couple of these indentations. But yeah, great solutions there. Yeah, nice job. Okay, this is student number 7.
I believe now it's really longer than, or I mean really longer than before. So the first thing I'm going to do is I'm going to create an array to store the result of a string. So
All right,
string
great.
result is equal to initialize an empty string to like build the result of string progressively.
Nice. Yeah, and then just, you know, I've said this across the last several videos, but I'm listening for your narration more so than your code. So this was 2 really good examples of you told me why you were about to make a variable and then made it, and then you told me why you were making this one, and then you made that. So I know this one is to store your result because you said it and because you called it result, which is great. And then I know that this one is to do your concatenations because you said it, and because you're about to call it current string or something like that. Could be a string builder. That would be a little bit more efficient, as I've said before, but string concatenation's not incorrect.
I'm making a loop to iterate through each and every value inside of the string array. So for
Yeah, and another good narration there. Instead of just telling me I'm making a loop, you're telling me I'm making a loop to iterate through through the values. That's the subtle difference that I'm listening for. So hopefully those of you, if I ended up taking off points, hopefully hearing some of the other students do their narrations will help you in the future. So everything's going well here so far.
Yeah, bases from the current string.
Mm-hmm. Yep. Yeah, okay, interesting here. So replace all / s replaces all spaces. Yeah, and I guess the fact that you say replace all means you don't need to put a plus here. Plus would be one or more spaces, but you're replacing all single spaces, so that also happens to replace all of the spaces. Yeah, okay, interesting. I didn't think about that the last time I saw a solution like this, like a few videos ago, but yeah, I guess you don't actually need the plus.
Down this more the current string and the result array. And then this needs to return the result.
Yep, cool. Yep, so concatenating onto the string and then storing each of those concatenated results into the appropriate slot of results. Yeah, that should do it. Nice. Yeah, okay, cool. Very nice. All right, let me skip ahead to find the next square.
Perfect squares. Let me just write this over here. Good. Is an integer. Then I'm going to find the next perfect square, and that's pretty much it actually. So if the root times the root is equal to SQ, then next square. So I'm going to copy because I'm going to use it later. Square root is equal to root plus 1.
Okay. All right, minor thing here, indentation. Indentation's a little off. Also, you are mixing up, this is not wrong, it's just something Java programmers will notice. You're mixing up the casing conventions. Like if this one starts with a lowercase and that one starts with a lowercase, then this one should start with a lowercase as well. In Java, usually the only thing that starts with an uppercase are going to be class names. And so if someone sees this variable later on, like away from the word long, they're going to think that it stores some kind of weird type, like a next square root type defined in some class somewhere. So we look for like lowercase and uppercase to give us a sense of what kind of thing it is. And so especially in Java, this should be lowercase. Now the Java program doesn't care. It'll run it either way. But Java programmers have habits, and we, this is a kind of big one. I never see an uppercase variable name if that variable stores a primitive type. So primitive type variable names, always lowercase, and then camel after that.
Return times plus root. Okay. So if the root times the root is equal to SQ, this value here, then it's going to return the next square root times the next square root. Okay. Else, return.
Yeah. Yeah, so I think this is going to be correct, and it's basically the same same critique that I've had of previous solutions like this, which is just that the math is a little bit magical. Maybe it was all obvious to all of you, and that's why no one's explaining it. But I thought it was some magic in need of some explanation.
7 kata. I had a little bit more difficulty, or a little bit more trouble with the 8 kata ones, except for this one. This one took me a long time to do. Well, I'm guessing since it's our first time doing 7 katas, you gave us easier ones, maybe.
Yeah, I actually tried to give mid-range 7th Q problems. Some of the 7th Q problems are so easy that they might as well be 8th Q, and then some of them I think are like extremely difficult. Well, not extremely, but like compared to the average 7th Q problem, they ought to just be 6th Q problems. So I tried to give you ones that were harder than the last week, like significantly harder than module 3, but not something so hard. The assignment today will be some more difficult ones, but you'll have fewer of them, so it won't be quite as bad. But yeah, interesting. I'm always interested to know which ones people struggled the most with. This one, I think, I thought this one was maybe the most sort of straightforward, although that might be because I've played a lot of Minecraft, so I don't know. Everyone's gonna have different ones that they struggle more or less with. I caught a glimpse of your previous code and it had a hash map in it, so I'm pretty excited to see your use of hash map here. Let's see.
So the first thing I'm going to do with this one is I'm going to import a Java utility. So java.util.hashmap.
Yeah, all right, here it comes.
Gives me more things to use when I'm writing the code. Then I'm going to create a new hash map. So
Okay. So what I'm listening for here is if you're going to explain to me what a hash map is, either directly, like you're going to say, hey, here's what a hash map is, or if it's going to be clear from how you're using it what a hash map is. And I'm on guard because I'm pretty sure hash maps were not something that you covered in Java 1. So it's something you found somewhere else on the internet. So I just want, to make sure that something that you found somewhere and you're importing into your personal Java tool bag is like something you actually have some like ability to articulate your understanding of. So we'll see. That's what I'm listening for now.
hash map string integer. Close that. Integer. Close that. Then counts.
I'm gonna skip ahead because that's just
Then we
boilerplate.
a for statement to iterate.
I will explain this though, just for other students watching. So a hash map is a special Java data type that maps keys to values. And in this case, because it's a hash map of string to integer, you can tell from the type right there inside the angle brackets. It's a string to integer mapping, means the keys will be strings and the values will be integers. And so what I'm thinking you're probably going to end up doing is mapping strings like sticks and cobblestones and stone to integers like the number of those things that there are. Which is interesting. Why not just use variables like the other solutions? But who knows? Maybe there will be some. Maybe it'll be clear that there's some advantage to using hash map. I have to think about it though. I'm not sure I can anticipate why you would use a hash map. If it were an actual game, so I have looked a lot at like the Minecraft source code, or at least a lot of the source code for doing Minecraft modding. If you were making a game, you would definitely use a hash map to represent like the player's inventory or something like that. It's the classic use for a hash map. So maybe a justification for using that in this problem is just to be closer to the data types you would naturally use in video game development.
Through each material in the array.
All right, so yeah,
And count the current material.
looping over the array.
Int or default. Counts.
Yeah, okay. So now we're putting something into the hash map, namely the material is the string, and that's going to map to, a little hard to read, but whatever was previously in that hash map for that value. And -1, why -1? Yeah, why not 0? I don't know. I can't figure out why you're doing -1 there, but maybe it will become clear.
Then I'm dropping out of there. Then I'm going to retrieve the count of the cobblestones, then retrieve the count of the sticks, then retrieve the count of the wood, and then
Oh, okay. So this is a good justification for using the hash map, because as you've all seen in the previous solutions, there have been 3 variables up here, and inside the for loop you set all 3 variables. But you can now, because you have a hash map, everything you see you can just throw as a key into that hash map along with a value. Oh, okay. No, okay, I guess I'm still not convinced. So all this does is initializes the hash map with all of the materials that exist, and it's set to -1, basically. So I think you're gonna now have to do another loop. I don't know. I'm still confused. All right. I thought I saw the reason for the hash map, but now I'm realizing I was wrong. So at this point, this would be a nice time for you to print out your hash map or something to show what's in there, because I'm thinking it's going to be a bunch of strings mapped to the number -1.
I'm going to count the total number of sticks by converting the wood to sticks, and then I'm going to calculate the maximum stone and sticks that I have. After it does its calculations, then I'm going to return that value. So this is basically a copy pasta here.
Okay, so you get the number of cobblestones. All right, nice copy paste there. Okay.
Then I'm going to calculate the amount of pickaxes that can be crafted with these material at my disposal. I'm going to call it max crafted. Max dot stones divided by 3, then sticks divided by 2. Then I'm going to return max crafted.
Man. Oh, okay. Okay, I think I'm getting it. This because this -1 compounds. So the first time you see a cobblestone, it'll put cobblestone in as 0 minus 1, so it'll be -1. But then the next time you see it, it's going to get the -1 and then minus off another negative. So it's pretty... I think that's a negative. Maybe I'm just confused because that's actually a positive and it's like showing up weird on my screen. But if that's a negative, I think it's a little bit weird. You should just make it a positive. And then you're like counting positive numbers for each of the materials that go in. That is one thing that would make it less confusing. This -1 threw me off. But I guess you can divide negatives and it's fine. So if all you ever need to do later on is division, then it's okay to use negatives, so it happens to work out. But then and then we do the division trick like we've seen in previous ones. Yeah, I don't see any reason to use a hash map here. Unless you just wanted to like learn about hash maps, I would say like a better solution here would be to just use regular variables, kind of as in the previous ones. Because if you reach for these like power tools when you don't need them, then it might be because you're not seeing how you could use the like more simple tools like hammers and nails. Maybe you did. I mean, maybe you do understand how you could use the hammers and nails and you just wanted to try out a power tool, which is totally valid. There's nothing wrong with that. But I guess my advice to you is if you weren't able to see how to solve this with just regular variables, then definitely take to heart some of the previous solutions we've seen in this video. Oh, okay. It is going to run into problems, yeah, because we're getting negatives. Yeah, all right. So it doesn't work out because when you divide the negative numbers, you end up with negatives in your max crafted. So okay, so now I'm actually curious if you're gonna find the bug.
But I have a feeling that it's because it says capital C, not capital S.
Okay, yeah, good catch there.
No.
All right, good guesses. All right, I'll skip ahead. Ah, you found it. Okay, nice. Actually, I want to find the moment you found it. I'm curious what clued you in. Yeah, so this is normal. Like as coders, we do tend to spend at least as much time debugging as writing code, at times at least. So nothing wrong with that. It looks like you kind of read through it and eventually found this line. Let's see what. Ah, yeah, okay. It didn't fix it, but things changed. Because before it was saying expected to, but was -2. And then you added the plus instead of the minus, and now it's saying expected to, but was 0. And it's because of some of your earlier debugging guesses. Because I think this said cobblestone before, but now says cobblestone. So let me find out. No, actually, okay, no, that bug was in there earlier. Yeah, you did camel case, cobblestones, sticks, and wood. Yeah, it looks like it's cobblestone singular, but sticks plural. That's actually like a confusing thing about the problem itself. So, okay. Yeah, so you fixed. This is a classic problem of if there are two bugs in your code, it's really hard to find them because this exactly what happened here will happen. The plus, you fixed a bug, but it's still not working. And so it's hard to tell you actually made progress here because still red and things changed. So that's why wherever possible, coders try to build up habits that prevent them from ever having two bugs in their code. Only ever want to have one. So that's why we move fairly slowly, testing things as we go, but that yields significantly faster coding output because we're doing less debugging overall. So slow is fast is the moral of the story. Yeah, all right, looks like you found it there. Ooh, was there a third bug? Okay, so you fixed 1, 2. Now what's wrong? Expected 4 but was 0. Cobblestone, wood. I don't know actually, what is wrong? Expected 4 but was 0. Oh, well, do you want to say max here? I don't know. Let's see if you find it. I'm not seeing the bug.
Get void default. Wood to count dot get void default. Oh, I never calculated the total number of sticks when I converted it. So sticks is to wood times 4.
Nice. Okay, good catch. Yeah, I totally forgot about that. Yeah, but yes, sticks gets or wood turns into additional sticks. Yeah. Okay, so wood was basically an unused variable. So line 13 int wood never got used after that. And some editors like Eclipse will tell you if you're defining a variable and not using it because it's almost always some kind of bug. But in CodeWars it doesn't tell us. So nice, good catch. Yeah, good. All right, very nice. Yeah, so those were several very good solutions. Could have used a little more explanation on the perfect squares. I've forgotten about this one. Let me just pop back here. Oh yeah, no, this one was good. I have no space was good. Could have used a string builder. And this last one, nice debugging. Don't necessarily need a hash map, but cool that you used one. Always good to try new things. All right, awesome. Okay, next video. Okay, this is student number 8, I think.
For video, I'm just going to go and start with the first problem right here.
Okay, out of space.
So, where is length? So string array length.
Putting it on double speed here.
Semicolon to close it. Then down here we're going to do result. 0 is equal to array 0. Now explain this real quick. So what we're doing right here is grabbing the length of this array and setting it equal to this array's length, so we have the same length. So that we're importing the tester class into this class. So we can test it, and we're also what this is doing right here is it's setting the first index of this array. So it's grabbing this array's first index, meaning setting this array's first index to the same. So if they're both the same, we're starting off the same. And we're doing for loop. So we're going to do int.
Okay, but why? I'm actually genuinely puzzled. Why are you doing that? I have to like think about it to figure it out. I mean, I what you said is all correct. That is definitely initializing an array of the same length, and you're setting the new array's first one to be the same as the input array's first one. My guess is you probably don't need line 5. You could probably do that inside your loop, but let's find out. I'll go a little further here. Oh, okay, okay. So if you initialize the 0th one outside the loop, then start on the first one inside the loop, then you do need line 5. But I don't know. Maybe you have a justification for doing it that way, but seems like it could be simpler. But let's see.
So what we're doing now here is we're starting at the second index because we already set the first index. We're starting at the second one.
Okay.
And then we're going to go to result I is equal to result I minus 1, that's one that has 1 in a second, plus array.
Oh, okay. Okay. Yeah, so this is similar to the one where you basically look at the previous one and add it on. Okay, yeah, no, it's actually exactly the same. So then it makes sense why you'd want to set up the first one so that you could look at the previous one. However, couldn't you... I bet you could just avoid that and look at array right here. Couldn't you say result I equals array I minus 1 plus array I? And then start your for loop at 0? I'd have to test it to be sure, but like it seems like you might be able to do that and then not have to do line 5. But obviously, I'm not taking off points for things like this. I'm just trying to give suggestions for ways that you could like think about the code differently and write it more simply.
Here is, let's take this for example over here. So the first index of the array would be I, which is right here, so it would be I right here. And then, so I would be 0, and we're starting at the second index. So we have
By the way, love what you're doing here. Like actually taking the sample input and talking through what your code will do on that input. That is a big way to show that you like understand what you're doing. So kudos on that one.
grab the first index right here. We're going to grab the current index, which will be the second index, which in this instance we have. And convert. So it grabs I, half, and it grabs it and puts it into one variable, so it's I half. Then it loops through again, so it grabs the previous variable, or the previous instance, sorry. And it grabs the current instance, which in this instance would be no, and it loop through again. So it would be space, and then the previous one, until the array is done. And
Yeah.
then return the result.
Awesome. And then does it work? It does. Nice.
So we're doing square root, and then we're doing the math, square root function. And then we're going to set equal to a variable, so we're going to call it root. And we're going to get long. And we're going to do an if statement, so if root times root does not equal SQ, then we're going to return -1.
Yep.
Yeah, return -1. And so I'm going to explain this as well. So in this instance, it would be, let's take 121 for example, it would be 11.
Oh, yes.
It would be 11. So it's coming in as 121. It's turned to 11 down here, puts in this variable right here. So right here it's 11 times 11 and be 121. So we want to go to this section, we go into the next one.
Yes, that was awesome. The use of the calculator here was fantastic. Like that makes it very clear. I guess I would have liked to see also an example where it, maybe we'll do this in a moment, but you showed how it gets into the else, but how does it get to line 6 would be if it doesn't have a perfect square. So it might have been nice to see that too.
So else, oops, actually, we just need to use this return, or root plus plus. And we go down here and do return root times root. And so with 11 down here from the previous example, so it would be 11 right here. We would do 11 times 11, 8 equals 21. We wouldn't touch this section, but go into this.
Yeah.
11 to 12, so it would be 12 times 12, and you get 44, or 144. But if it weren't a perfect square, then it would go through this instance right here, calculate it, and it would determine if it wasn't square root, it would turn out and exit the code.
Nice. Okay.
Nice.
All right. Nice. Yeah. So you explained both branches. Super good. I like it. All right. So now we are at the Minecraft one. Looks like that takes the rest of the time. I'm curious. Yeah. Maybe this was the more challenging one.
And this is the sticks, or the Minecraft.
Okay.
0.
So we do the 3 variables trick or 2 variables trick.
So that's our array here.
Oh yeah, because wood can be calculated on the fly as 4 sticks.
And then using 2. And, check for sticks in the first one, and then do sticks plus plus for every instance.
Wait. Is 2 equals actually a method? Maybe you meant to say equals. Maybe 2 equals is a method and I've never heard of it before though. So it's possible. Who knows?
If material, so cobble.
Okay.
If you have wood, let's say for the current instance, wood, this would be wood to sticks. No, we go with what we gotta do down here is return. Actually, not gonna create another variable. We gotta create the. So now, oops, yeah, I forgot. Okay, and then I gotta break out down here.
So there is something piling up here with the... Oh, there. Okay, yeah, you fixed it. Perfect. Perfect.
Okay, this one's easier. So I'm sorry, right here, so if I have 8, take x. None is equal to that main, I'm just gonna cancel the x row. So we're gonna do 6 divided by 2, and we're gonna do cobble divided by 3.
Okay, yep.
The overall stick count divided by 2, then we're gonna do the overall cobble count divided by values. Here, that's the lowest one. And we're gonna return
Yes. Nice.
this material weapon.
Oh, what happened there? Oh, yeah, okay. You just fixed all the 2 equals down to
So
equals.
So let's say wood. So it compares it. So it says, is this piece of wood equal to the sticks? No. So it goes down to here. It says, is this wood compared to cobblestone? No. So it goes down to here. And it says, is this wood compared to wood? Yeah. So it increases the sticks count by 4. And then it breaks out after a while. And it says, or what happens is this variable is equal to the lowest out of these two. So divide all the sticks by 2 and all the cobble by 3. And put into this variable. And we return it. And it compares it to 11 values down here. So like this 30, this 24, this 16.
Yeah. Yeah, that's awesome. Great. Great. Yeah, nice job. It's a good job explaining exactly what happens, comparing it to the outputs, and even matching it down to the test cases here. Awesome. Awesome. All right. Very good. Okay. All right. This is student number 9.
Space thing, which is basically just actually cramming the words together. So not much
Yes, exactly. It is. It's just cramming the words together. I love it. Yep. All right. Let's see.
Oh, yeah, new string.
Yep.
0. So again, I came up with this method. Just uses some too close to for my liking I, but I'm gonna change to that. So I'm gonna do this, and
Yeah.
basically,
Okay.
we're just going to make it so we do new array I equals array I. Then simply how we're gonna get the thing to like cram together, as I call it, is make a array thing like this. That word 3, word 2, word I messed up, and word 1,
Oh.
and the end is the new array.
Okay, I gotta process what's happening here. So, okay, so here, line 7 makes sense. So you're putting new array sub I equal to array sub I. And then you're going to, I guess, concatenate on the previous ones. Now, word 3, word 2, and word 1 don't exist yet, but I think you're just trying to illustrate the concept. So let's see.
Right, so basically what this does, let me catch them in the variable and all this stuff so it's easier to see. Let me make all this, should be pretty easy to make, just copy and paste if I do this.
Oh, okay. Oh, you're using a string. Okay, gotcha.
Empty, so I'm
Gotcha.
gonna this. It's not, there we go. Alright, I'll copy and paste that down.
Oh.
Okay, so this is gonna do, you're gonna take the strings, it's gonna go through right now. Nothing in the strings, so it's gonna go, so the one, the first I can, each one after the other, so after it's been used, assigns to the next one, basically. It's right like that.
Okay. So that would work. Something like this would work, but only if there's a fixed number of strings in the array. Then you could have a fixed number of variables to store your previous words. So I'm thinking this won't work unless all of the... maybe every single one of the tests has exactly 4 strings in the array. I guess we'll find out. Fast forward here. And, whoa. What happened? Did that actually work?
So now, bases. Yeah. And then it'll go through, and it'll be has, and then it'll be, then has no, and then can has. So basically, go through all those with this little word thing. There's not really much explanation, that's really simple. And I think I'll do is just new array. So yeah, it's actually very simple.
Does this work?
Oh, there we go.
That worked. Well, it worked on these. Does it work on the other tests? Didn't run it. Okay, so I'll probably take off a couple of points for that one because I don't think the solution's fully correct. Feel free to message me on Canvas though if you disagree. But if there are more than 4 strings in the array, which the problem didn't say there couldn't be. I don't think the problem said there are only ever 4 strings in the array. So I think that your solution only works if there are 4 strings. If there's a 5th string or a million strings, then it won't work to just keep a history of the last 4. You'll need to do something like some of the previous solutions you've seen in this video. So, but it was still not a bad solution. There's a lot of good stuff that in that solution. I did like how you explained it. Like your explanations were super good, so you won't lose a lot of points, but just a couple because I think it's not quite right. All right, yeah, now that was a good explanation of the math there. So now let me just see if your code shapes up.
Square is. I'm messing up now. Is that this right here? Well, that's okay. This is the way I did. Okay, so I followed this. So the square is divided by 2. The remainder is equal to 2. Remainder 2, which is 0. Then it is also even first order. And I did the same thing again, except so between 2 you make 3. So basically, if it's either a remainder of 1 or 0, it's probably an actual like a whole number. That's basically.
So you're trying to check if it's a whole number here. Square root mod 2 equals 3 mod 2. Yeah, I don't know if I follow the logic here. If you want to check if it's a whole number, you could just mod by 1. There are a few ways, and we've seen them in previous videos. A few ways you can check to see if something's a whole number, but I can't quite see what's going on here. Square mod 2 would check if it's even. It would be 0 or 1. So then checking to see if it is equal to 2 would never be true. But then there's another mod 2, and so I think this parses first, and it would be like 2 mod 2, which would be 0. So you really are checking square root of 2... square root mod 2 equals 0, but in a way that's very confusing. So yeah, I don't know. At the very least, this part I think should be 0, or you should put it in parentheses to kind of clarify what parts of the math you're expecting to run first. And then I don't really get the or over here. I guess I could listen to your explanation, but it just doesn't strike me as correct. So let me just see if you actually end up getting this right. Wait, what? Okay, I gotta listen.
SUR plus 1. Now we do that. What to do is times num by itself, so we'll make this num SUR, I guess.
I'm also confused by the word numhold. But I see what you're doing here. You're squaring it. Okay. Okay, so this variable is just to convert it to a long, and then you return it. Okay. Okay, that once again you have mystified me by how you got this to pass. I will admit this part here is more complicated than it needs to be. I think you could simplify this, but if I just kind of blur my vision and don't think about that so much, I just think about it as the way you described it, which is to check for if it's a whole number, then you're actually exactly right. I'm just confused how this is doing that. And there are easier ways to show that something is a whole number, just to show that your code is checking for whole numbers. This, I think, would make most Java programmers be like, wait, what? How is that working? So yeah, I guess full credit for this one because your explanation was good, and I'm just confused about one part of it. All right, last one.
So we're gonna do a string item that's just so when we go to the right, that'll be each of the processor items that we have these. And then we're gonna make a Bowser count. I always make a Bowser count actually. So say Bowser.
All right, so you got your counts.
Now what we're gonna do is make a. It's just already this time.
The one thing I'm confused about is what you're going to use string item for. I don't see a need for that just yet, but we'll see if it comes up.
Last time I saw. Last time it was already. Pretty sure what I did was. So what was this actually? Pretty sure all this was. So the bunch of if statements. 3 exactly.
Oh, okay. If your string item is just for storing what's in the array while you're looping over the array, you should put that down here. Because the fact that it's up here in global makes it seem like it's going to be used outside of your for loop. And we'll see if that happens, but I'm thinking it probably isn't. And so putting that, just basically nixing line 4 and just saying string right there in front of line 9, that would be much clearer, like what that variable is actually doing. Because global variables tell programmers that they're used globally and they need to like think about them in a global way. But it's now seeming to me like it's not that way.
If your track item, if item equals cobblestone, right, cobblestone count? No. Cobblestone, I think it's, do I got like that? It's cobblestone, so it's exactly this. Some of the is exactly.
Yep, good copy paste there. Yep. Yep, then you increment your variables. Nice. Yep. Yeah. Yeah. Yeah, so that, again, I like this solution. You're going to loop over and basically increase pickaxe count. And I think you could safely move pickaxe count, line 7, down to right before your while loop. Because in general, it's nice to group your like logical thoughts together. And pickaxe count gets defined up here, but then like doesn't get used for like a lot of code until finally you start manipulating it down here. May as well just initialize it right before you're calculating it. It would make things a little bit clearer. But it's not wrong. Well, I guess it's not right yet until you actually increment pickaxe. But I think you're about to do that probably. Okay, so you're going to take out your ingredients.
Minus 2. 2. Now that we just got to do pickaxe count plus plus. Each time it does that. So basically this is simple. It loops through. If we have enough 6 enough 1,000, and if we do, minus the from the stack, and we make as many pickaxes as we can. And that's always been quite simple, honestly.
Yeah, perfect.
I mess up at all. I might mess up.
Perfect. Yeah, that was great. That was awesome. Yeah. Yeah. So just a couple of things you might be able to clarify based on where you define your variables, but the solution here is really nice. And you explained it well. Nice. Good job. Okay. All right, next one. Okay, this is student number 10. Okay. Making results. I am having trouble hearing. Okay, string builder solution here.
Right, now we're gonna loop through each word in the input array by just doing a simple for loop.
Okay, could also use a for each loop here. But good job telling me that you're looping through.
We'll append the word to the string builder. So we're gonna each iteration we're gonna add the previous word to string builder.
Great narration there.
Convert the string builder and then convert string builder next with 2 to another string, and then we're gonna store it in an array.
Yep. Oh yeah, perfect. Good solution or good narrations. All right, some debugging initiated here. So cannot find symbol words. So we find the first time words happens, and then when we look earlier, if it says cannot find symbol, we need to find where should words have been defined. And then if we don't see it, then we've actually found the bug. Yeah, nice. Nice. Yeah. And that's one possible fix. You could change it there in the parameter, but you could also have left that the same and just change words in 1, 2, 3 places to array instead of words. But this was faster. Just rename the parameter.
There we go.
Nice. All right.
Alright, so with number fun, basically built in Java, so using root equals, let's say math dot square root.
All right.
We're going to be checking the square root equals the input, so to determine if it's perfect square, so it's if.
All right. Indentation there could be slightly improved. But yes, you're checking
Square, then we'll
checking for perfect, or for whether it square rooted evenly.
root. Times root plus 1. Okay. Alright. Something else. Else return.
Else return -1. Yeah. Okay. Okay. It's the same thing there. Yeah. I mean, good solution. Ooh, indentation definitely needs to be fixed up a little bit. But the logic is there. Just, still has the same kind of mathematical magic to it that I think could have been clarified a little bit better, but that's okay.
Calculate the numbers on pickaxe that you crafted, basically given an array of items. So based on that, you got to spit out how many stone pickaxes you can craft. We're going to start by initializing sticks and cobblestones
All right. Yes. Sticks and cobblestones.
down below.
All right. For each loop to loop over them.
Add stick.
Checking for string equality. Indentation's doing pretty well here. Good job on that.
Plus we're going to add another iteration of cobblestone.
Could probably have cut and paste to construct your if else faster.
Else if. Alright. And now we're going to calculate the minimum number of sticks. 5 by 2.
Okay. Yep. And then you calculate number of pickaxes with the
5 by 3.
division trick.
It requires 2 sticks and 3 cobblestones.
Okay, student number 11.
But from what I understand of the inputs and the output is that pretty much we are going to be taking any element, any index of this, and concatenating with all previous indexes. So space would have, I have no plus space in it.
Yep.
And
Nice. Good.
that kind of points us in the right direction as to what we need to do. So first thing I'll do here is build out the result. And then
Alright.
length of this array is just the
So you,
have, I have, and no, plus all the stuff that came before it. So it's just gonna, it's gonna be the same length. Really long way of saying that.
yes.
Array dot.
Same length.
And here
Nice.
I'm going to be making a new string that concatenates all the previous strings before it, right? So I'll call this the
Okay.
accumulator.
Yeah. Great narration so far. Everything's awesome. Just pointing out string builder here. It's probably the best tool, but not the only tool.
And then all the elements within it successively concatenates them all. So for integer I equals 0, let's say the first index, as long as I is less than string, yeah, string array, so array dot length, then you know, I.
Yeah, for each loop could be a little bit cleaner here if you wanted to.
Open curly, close curly, one. So this pretty much concatenates strings together.
Mhm.
This should be
I like that you called it accumulator because this is, an example of the accumulator pattern. That's something that we'll see, probably have already seen it in a few different Code Wars problems, even though I haven't explicitly labeled it that. But the accumulator pattern is where you have some variable, and then inside of a loop you add to it, concatenate onto it, append to it. What you do is not important. The pattern is that it's just getting bigger and growing more and more as your loop runs. So that's called the accumulator pattern, and it comes up in a lot of programming problems. It's a very standard technique.
array dot I, right? Because we're going to the
All right, so you
accumulator.
concat that one on, and then
So
stick
just
that one in.
go so like for an index of 3, or where it's 1, 2, 3, then I'll add the string 1 to empty, so the first one will just be 1, and then 1 plus the next index 1 will be 2, so on and so forth. 1, 1, 2, 1, 2, 3.
Yeah, great. Yeah. Good explanation of how the loop was going to run.
Return our result.
And then does it work? It works.
We
we
All right.
pretty much take a number and find the next, and if it's a perfect square, we're going to find the next perfect square on it, right? So 144 would be 13 squared, whatever 13 squared is, because then that's still squared. So we'll go ahead and start building that out. First, we want to calculate the square root of the number that's being put in, right? So let's find the square root. Actually, I'll stop it there. We're going to be using the math function, right? And it has a square root method in it. So that return value that it gives us is a double. So what I want to do over here is typecast that into a long, and that's important.
Yep.
So this will typecast it back into long and just truncate the rest of the decimal points off. And so we can tell that
Nice.
it's a perfect square because if we square that truncated value that had decimal points after it, it won't return to the same value we did before. So we're going to go ahead and do root times root, right? So we're multiplying it by itself. And if it wasn't truncated, it's going to, if it was a perfect square to begin with, then it'll just return to its original form. So if root times root equals the input value square, then we will return, this is the pretty easy part, root plus 1, because the next root, right, like, so if we had 11 squared, the next perfect square would be 12 squared, so just add 1 to the root, right, times root plus 1. Then we can go ahead and do our else statement here, and if it's not a perfect square, then we're just going to return negative 1, so return negative 1. And I don't need
Yeah.
expressions.
Yeah, this is great. This is perfect. Yeah, good explanations here. I like it. All right. Maybe you could fix 2 places where the indentation's a little bit off, but yeah, it's a good standard solution there. Yeah, good.
X or 3 cobblestones. So let's start building that out. And the way we're going to solve this is just count our sticks, count our cobblestones, and whichever one is our bottleneck will be the maximum amount of pickaxes we can make. So I'm going to start off with a stick count of 0 to start our counter, and then cobblestone count 0. For each loop. So
All right.
String
So you
value, like in here, we'll compare.
All right, so yeah, so now you're using a for each loop. Yep. So that could have been useful earlier. But yeah, so this is good. You have your variables, and now you're going to use a switch statement to decide which ones to increment.
This to one of the constants that we're going to define here. So switch item, we're going to do item in the array, and then we'll write our first case here, which is sticks. If that item sticks is equal to sticks, what we'll do here is we're going to
Okay.
iterate on sticks. So stick count plus equals and then 1.
Yeah.
What this will do is it'll
Yeah, so this is the more traditional syntax with a colon and a break. That's why earlier I was surprised to see the arrow syntax, but apparently you can actually shorten this up by doing an arrow here and then omitting the break. Very cool. I also notice you don't have curlies on your for loop, which works because there's only one line inside your for loop. It's just that line is a very long line with the switch, so it threw me off at first, but that's totally valid.
So it will do in this case, if I didn't have that break, it'll
All right, so I'm just going to skip ahead till your
fix. So,
switch is complete.
and doing some division, seeing which one will be our bottleneck for how many pickaxes we can make. So max pickaxes. That's just a simple math problem, it's just stick count. And we need 2 sticks to make a pickaxe, so that's why it's divided by 2. And we need 3 cobblestone to make a pickaxe as well. So by cobblestone, this will be a long variable name. I just for the purpose of this, it's just making it really clear what we're doing here. Right?
Yeah, I love that. This is great. Yeah, so oftentimes the more variables, the better, because every variable is a chance for you to give your own name to some part of the code. And every time you're naming a piece of code, you're explaining it. So, well, if you choose a good variable name, you're explaining it. And these are great. Yeah, so this is the first time I've seen a solution where someone gave a name to these divisions, and it makes it very clear what like why you're doing the division. So nice, yeah, awesome.
This is variable name in the bigger project, cobblestone count. I think you can compare which number is smaller, and that'll be the limit of how many pickaxes we can make. So
Yeah.
minimum function. Then we can do this with like if we have like 3, if we need 3 items, we can also do. It'll just choose the smallest number between these 3. And there's actually these values, like let's say we have 5 divided by 2 is 2.5. It'll truncate the 0.5 and just be 2, right? Which is what we want. We want the lower. We want to round it down so that we have whole pickaxes, not partial pickaxes.
Yeah, nice.
So we have 5. All right. Let's see return.
And you're just missing a semicolon. Perfect. Yeah, that was awesome. Very good. Nice. Nice. Okay, student number 12. Oh. All right. Oh, let me put it to double speed here. Okay. Yeah, so the fact that you said add previous string to next string tells me something about the solution that I think you're going to write, which is the one where you look at index I minus 1 and you add that onto index I. Let's see if that's what happens. Yeah. And now my hypothesis is confirmed because you're beginning immediately with a for loop, no additional storage. So that tells me that you're going to manipulate this string array in place. This is probably the fastest solution, like the one that would run the fastest and use the least memory. It also happens to be the shortest one, so probably a good one to look at if you did it a different way. This is a solution that's probably, I would consider, the best. Well, I don't know. I haven't seen it to completion yet. There might be problems with it, but if it's going the way that I think it's going and the way we've seen in a couple of previous videos, then I think this is like one that would be considered the optimal solution. You could, though, use a for each loop here to just clean it up a little bit. No, wait, you couldn't. You couldn't use a for each loop because you have to look at the previous one. So you need I so that you can do I minus 1. So I stand corrected. You need to have the traditional for loop syntax here. Good catch. Yeah, you want to start from 1 because the 0th one has nothing before it. So if you're going to start looking at previous ones and adding them on, you have to start at number 1. Yep. I think you could just do plus equals. Oh no, then it would have gone up. Then it would go on the end. If you want it to go on the beginning, it has to be like this. Yeah, all right, good.
So that should give us basically everything before it. So this first one should turn into this. But now once we get to no, have should now turn into I have. So we don't have to double that.
Hey, nice. Good printouts. I like it. Yeah, and we get to see it evolving right there. Yeah, fantastic. And we get greens. Nice. Okay. All right, perfect square. Okay, yeah. So that's probably the tightest way to check if something is a whole number. So square root it, and then mod 1 not equals 0 means it's not a whole number. Because mod 1 equals 0 would be 1 divided into it evenly. If 1 doesn't divide into it evenly, then it must be a non-whole number, in which case your ternary is going to return -1. Whoa. This is a two-liner solution. It's actually very, very tight here. So let me absorb this. You square root it. Go ahead and add 1 onto it. That's pretty clever. Okay, so you go ahead and add 1 onto it because that can still be checked for whole numberness right here. Adding 1 doesn't affect that. And then it's ready, if it happens to be a whole number, it's ready to be rounded and squared. Does it need to be rounded? Or that just turns it into a long so that it matches the type. Okay, yeah. So it's ready to be squared, and then you round it down so that it becomes long. Yeah, nice. That's great. Hey. Okay, wow, this is awesome. And the first time I've seen someone pull up the documentation during their video, so this is also a great way to both show me where you learned something, prove that you understand it, because this is like the manual, the Java manual. Tells you whatever the function is. And by the way, there are thousands and thousands of Java methods out there. more than any one Java programmer memorizes. Like, we don't memorize this stuff. We look these things up, and then we remember that they exist so that we can, like, find them later. But you don't have to remember round takes a float or a double and returns an int or a long. Like, that's the kind of thing, the kind of detail that you can just look up. And so I really like how you're showing me the round documentation page in order to show me that it returns a long. Okay. Yeah. Yeah, okay, so this is nice too. So you're actually you're reading the test code to see, like, kind of what is going in. It does put a string array in. You can also just tell that from the input right here, but good to connect the dots. It is hard to hear you. Whoa, okay, now you're blowing my mind. Why are you making a two-dimensional array of objects? I think this is similar to the hash map. I think you're about to use... but why is it two-dimensional? Oh, okay, because each... Is it because each inner array is going to be just having two things in it? The string and the value? That's a weird thing to do in Java because you usually will have arrays of all the same type. But if it's just capital O object, then yeah, I guess you can have an array of mixed stuff. So you're about to make an array of arrays, and the inner arrays are going to be pairs of strings to the, like, sticks or cobblestone, and then the second element will be, like, the number of those things. If you're gonna do that, definitely the hash map would be the best thing to do. That's like the built-in way of mapping strings to something else. Two-dimensional array of objects can work, but I think it's not as elegant. And then on top of that, you really don't need to be... Well, let me just see where you're going with this, but I am surprised to see this coming up. Okay, so it's not an array of pairs, it's flipped. It's like an array, and it's like the first array is columns almost. If I think of this as like a spreadsheet, it's like cobblestone, sticks, wood is one row, and then the row underneath that is the number of those things. So you are still, like, mapping. You're basically using this structure to map cobblestones to 0 and sticks to 0 and wood to 0. But if you want to map things like that, hash map is the way to go. But I'm excited to see how this one shapes up. It's just not traditional. Oh. I think you might be going the wrong direction here. If the array... Oh, no. Okay, I see. You're just covering, like, a base case. If the array is less than length 5, does that mean they can't have given you enough for a pickaxe? Wait, really? I need to think about it. Actually, don't know off the top of my head. What is it? 3 of one and 2 of another for a pickaxe? So, okay, fine, sure. If it's less than 5. But what if it's What if it's like the one where you get extra sticks? Yeah, it seems like you could have a couple of woods and a couple of cobblestones in there, and that should be enough for a pickaxe, even if it's less than 5. So I don't think this is gonna work, but maybe I'll stand corrected as it shapes up. Okay, yeah, this is... I think this is correct, but man, it is hard to read. Like, that's the drawback to structuring something as this, like, two-dimensional array of objects. But, yeah, okay, so you're looping over the materials, and then for each of those, checking if the first, like, the column matches. Like, we're looking at a cobblestone, so then we increment that appropriate value. Yeah, but it's kind of hard to read because the syntax of like this matches and then these double square brackets, I think at least for me makes it hard to read. So just using standard variables definitely gives you a lot more readability, but definitely points for cleverness here. I do like that you're about to do a print line here. I think that's kind of necessary when you're dealing with something so complicated. Like, you gotta verify that it's being constructed the way that you expect. Okay. Nice. Yeah, so you're gonna print out everything. Yeah, I'm very curious to see if you got it right, because like I think this is correct, but it's like there's so much syntactic noise that it's hard to know. So definitely I want to see like a authoritative word. So yeah, what will your print give us? Yeah, okay, cool. All right, so your logic is working, so can't complain there. So yeah, now just are you able to... I'm still curious about line 5 if that's actually necessary. It may not come in to play though, because there might not be any tests that are less than 5. But if there were, then it might be a bug. Well, let's see. So you've done your printout. Now, yeah, okay, now you extract out of your data structure your number of cobbles and sticks. Okay, and then that's where you add on the ×4 for your wood. Stick that into sticks at the end. Okay. Oh, if cobble is less than 3. Oh, okay. So you're just covering your base case. Might not have to do that. I think the min might take care of that, but not wrong. So if you don't have enough cobbles and sticks, then it's 0. Otherwise, we figure out how many with, I'm assuming, with the division trick. Yeah, and awesome. You're pulling open the math.min documentation. Okay, you actually don't have to do math.round here, because you're about to divide an integer by other integers, and it's going to give you back an integer no matter what, because that's just how integer division works. So the math.round here doesn't really help you. It doesn't hurt you, except that it makes this line a little harder to read. But you could omit that. Yeah, that's another drawback to doing this object array, is that now everything needs, like, you have to have casting everywhere, which just adds a little bit more noise. Yeah, nice. That was awesome. Yeah, very interesting solution there. All right, this is video number 13.
So the first problem, I have to remove the spaces from the value, and then return the array showing the spaces decreasing. So the first thing I'm going to do is create a new string array. So string,
All right.
string, and then inside it, so create a for loop.
Okay. All right. So we're seeing the string concatenation solution. Could use a string builder here. Also, oh, this is so minor, but just so you know, Java programmers almost always leave out the space before the square brackets. You can see, actually, it's like up here, string array. You have string space array, and then also right here, string space, and then your square bracket. Java, the program doesn't care, but Java programmers put those together. You can also see it right here, string square bracket. Kind of like one thing, because we think of it as one thing. It's a string array, so no space.
So for int I equals 0, and I is going to be less than the array length.
Nice,
we're
good.
going to set the combined.
Yep. All right, concatenate it on.
Method replace, and then we're going to a space, and then comma, and then no space.
Yeah, and let me quickly look up here, because I am pretty sure that Java's replace only does the first one in the string. Maybe not. Oh, wait, I'm confused now about the difference between replace versus replace all. Because some of you have used one, some of you have used the other. Is there a technical difference? Oh, okay. It's just replace all lets you use a regular expression. Yeah, that's literally the only difference. Okay. So replace can take a char and a new char, or basically a string and a new string. It says char sequence, but string will work. But if you want to use regular expressions, then you would use replace all. Okay, so I thought, so in some other languages, you can do a replace and it only replaces the first one, and then replace all replaces all occurrences, but I guess that's not the case in Java. It's literally just about regular expressions or not.
Semicolon, comma, set that equal to no space I, equal to no space.
Yeah, that's great. Perfect. Yeah, very good. All right, next one.
The argument itself is not a perfect square. You have to integer perfect square for the passing integer. Looks like it's long. I'm gonna put long.
Oh, okay.
Yeah.
Wait, already I am puzzled. Why are you doing a for loop? Let me back up a bit. Maybe you explained it.
Put long integer perfect square for the passing integer, passing parameter. So I'm gonna make a for statement. For, and then since the variable type is long, I'm gonna put long I. I equals 0. And then I times I is less than or equal.
Oh. Oh, okay. This is pretty interesting. This is a neat solution. So you're gonna loop, starting I at 0, and you're gonna increment I up until its square becomes larger than the square input, and then you found the next perfect square up. That's neat. That's a cool solution.
Equal to the square, and then I plus plus.
Okay.
And we're going to do
So I'm gonna put this on.
if statement.
Oh, yeah.
So if so this is where we check to see if it's a perfect square. So I times I equals square, and then
Okay.
variable is going to be next, and then for that, we're going to return next number, copy here,
is times the next number of we want square, perfect square. And then here, if it doesn't come back with a perfect square, anything other than perfect square is going to return the negative 1. So I'm going to test this out and see how it goes.
Yeah. All right. Yeah, this is very unique. This is a very different one. We haven't seen one like this so far. So yeah, looping up as long as the square is less than the input, and then you're going to double check, or like basically when it does equal it. Wait, does that actually work? I have to like think about this stopping condition in relation to this. Yeah, I guess so, because it increments first, and then it comes in and then you detect that it equals the square, and we're looping as long as it's less than or equal to anyway. So once you've detected that it equals the square, then you look at the next number up. Nice use of a new variable here. You could have just said I plus 1, but calling it next number lets me know that that's what you're thinking about as is the next number, and then you return that squared. And then if you got through this loop without it ever getting to the current perfect square, then it must not have been a perfect square to begin with. Cool.
Pass, and then we'll do the 10.
Yeah, that was awesome. All right. Okay, good use of comments there. I like it. Yo, yeah, this is great. This is actually a really nice technique, because there's usually a lot of just fluff in the problem. So just putting comments of the important things that matter, that's awesome.
We're going to create first one's going to be stick equals 0.
Mm-hmm.
I array I. We'll set that dot. We are going to put.
Oops. All right, it's got a buffer. It was looking good though. Yeah, nice. Missing some parens. Ooh, yeah, so okay. Good use of copy paste, but if you copy paste while there's a syntax error, it'll actually slow you down. So this is a case where some balance of running the code often, or just enough to make sure you don't have syntax errors, is a small time investment that'll actually speed you up, because it'll let you do these copy pastes without accidentally creating more work for yourself. So there's a missing not semicolon. Oh my gosh. Parenthesis. Sorry, this is video number 13. I've been doing this for several hours, so yes. Parenthesis is the word I'm looking for.
What? Not that. It's going to be opposite. And it's going to be opposite. I'll stay the same, so we're going to take sticks, copy.
Yeah.
Paste.
Also good copy paste there.
This should rock. And this is the stick, but we're going to have to add 4 sticks.
Nice.
The next part is so int 1 for the handle. You need 2 sticks to create the handle. And
Yeah,
int,
that's true.
is going to be x there. And then we're going to equal the rocks. Is it rock or rock? It's rock. Okay. And then divide that by 3. You need 3. So that, and then
I love that. I love those variable names. This tells me that you know how to play Minecraft. Yeah, because what are the sticks for? They're for the handle, for the pickaxe, and rocks are for the axe head. Yeah, very nice. Yeah, I mean, so that is another example of using variable names to clarify your thought process in a certain way. So, very cool.
we're going to grab the total. Great, one more. So int is less than. So C. And then so if the handle is less than x head, we're going to return the handle total equal to handle. And if it does not, then it's going to be the x head.
Ah. So you find the smaller one, because that is going to be your bottleneck. Yeah, okay, cool. I like the logic there. Because basically every pickaxe needs a handle and an axe head, one of each of those. And however many, whatever the fewest of those 2 ingredients you have, that's how many pickaxes you can make. So this tells you the total number of pickaxes. Just look at whichever one is less. Nice. Could use math.min right here, but this way is maybe better because you don't have to use a magic function. You're just using built-in, if statement ternary operator syntax here.
Let's see how that works.
Yeah, and so this is my one critique here is you've let your code get into a state where you have 3 bugs, at least 3. That's maybe more, but 3 that I've seen, and so you end up having like a lot of stuff to fix. Might have been faster overall to like be running a little bit more constantly.
And I can get parentheses on all of that.
All right, yep, so you catch the parens on both sides. Oh, what's going on there? Incompatible types. Oh, okay, right. You're just missing your double equals there. Let's see if you find it.
Oh, it's less than.
Or, okay, less than.
So there goes, it failed. So that means one. Yeah. 2 cobblestone, not cobblestones like happened last time. So there we go. I tested.
Yes. Nice. Yes, less than, not double equals. I misspoke earlier. Like I said, I've been at this for several hours, so already misspeaking. But this was fantastic. Really good solution. I like the variable names here, handle and axe head. Nice job.
In this first puzzle, it tells us the new create function that removes spaces from values and returns a ratio the space decreases. So maybe it's limited. So because we are saying it's array,
What? Sorry, I just have to call out your cursor there. Very, very eye-catching. I like it.
I'll have to create a for loop. We can look for data, we select the 4 points. And then I'll load the data up. So let's go to construct for loop first. So it's for int I equals 0.
Okay.
I equals 1.
Yeah, so the very fact that you're starting with for loop tells me you're going to do a particular kind of solution because there's only one kind of solution that doesn't use additional variables. And it means you have to be editing the array in place, which means you're just going to look at each one and add the previous one on. So let's see if that ends up
I is greater, or I is less than array dot
happening.
And then I plus plus brackets, and we create the first entire. We're starting with the first function, or the first element. Second element, sorry. First element 0, second element 1. So we have to backtrack on that to create array I, and we're out of bounds.
Yeah, small syntax error here. I minus 1, but I think you'll find it pretty fast.
And so what we're doing is we're taking array I minus 1, starting at the 0th element, and combining it with array I. My first intention, or idea, was to start looking at how to replace the white space. But there really is no white space, because it goes string, to string, to string, to string. And
Yeah, it's such a weird problem. The problem says that it's about removing spaces, and then the title is running out of space, but really the problem's about mashing together the previous things in an array. So maybe it's just trying to be tricky. But yeah, I think to pass these, you just don't have to do the space replacement. But many of you did that, and I think that's technically the correct solution because that's what the problem was calling for. It's just the tests that they make don't have spaces in them. It's a little bit weird, but I think that's the fault of the person who wrote the problem. So just keep it in mind. These problems are not perfect. They're authored by other programmers out there on Code Wars.
there's no spaces in it, so pretty much all you do is just like bunch it up, put it back into the array, and then put it in the array. So when we do it, when everything passes, we go down, and we attempt it.
Yeah, perfect.
It's actually forward.
Nice. All right. Let's see. Perfect squares next.
And look at all the other abilities that it has. So we kind of have to know it. So when we say start, so we go long r, I just do r for square root, equals math dot min, and no, so math dot square root equals sq. And we should get an error from this. So let's get our error. Our error tells us that it's incompatible type possible lossy conversion from double to long. So when we're going to square roots, we do need to.
Yeah, this is a really good example of running the code, even though it's not finished yet. Ran the code, see what the error is, and let that dictate the next step. Make sure that you never end up with multiple bugs in your code.
We go for square roots, we really use long because we use double it as it should. So now what we do is we create the new data zone. So it's if, and then we'll say the square root times square root equals sq. So we say if r times r equals sq, then we have a perfect square. So in that situation, we open up brackets, bring it down, and then we say return r plus 1 times r plus 1.
Yep.
And that should do that.
That's good.
Plus, and
The indentation here is a little bit off. I think this should be on a new line, or the previous curly should be up on the previous line, something like that. Or it's just a one-liner, so you could omit your curlies. That would be fine. And then you could put them on all in one line. And then this else should be tabbed in.
See, I'm kind of lazy. I almost start with code. I like to do return -1, and I even did it here, where I just kind of box it out and just kind of put it on one line.
You read my mind. Perfect.
And I know it's terrible coding, but for some reason it just looks so good to me. That the code's kind of clean, you just look and you see the line.
No, I agree. Yeah, this is fantastic. Yeah, if they are one-liners, put them all on one line. Get rid of the curlies. Curlies are ugly. One nitpick is just stick the else one character to the right or pull everything else to the left. But yeah, this is fantastic. Like this looks clean to me too. It's not just you.
We're able to do this simply because we're only doing one thing, which is returning information. If we have to do two or more things within our functions, then we do need to use the brackets. For this, because we're only doing one thing, we actually just get away. Everything works just fine. But for the sake of making it look proper, because I do want to work on that, even if this makes a little bit more sense to me, or at least it feels better. But we'll do it the way it's supposed to be. Just I don't want to make it.
Yeah, I think it's interesting that you feel like it's the way that's supposed to be. The way you had it before is the way I would write it. If it looks cleaner, that's usually better. If you see it like this, I mean, it's not wrong. I just don't think it's as good. But they're also both very close. Neither one is like that much better than the other. But there's no way that something is supposed to be. Like, you're going to develop your own style, and then you get to decide for you what is the way that it's supposed to be. That'll be a combination of your own preferences and the things that make it clearest to the people that you write code to, people on your team. You'll kind of collaboratively generate a style and find what works for you. So you don't have to put it this way, but it's good. It's good that you're demonstrating that you know both ways. So I'll go ahead and skip over to your next one.
Diamond, iron, this and that. Sticks and wood, cobblestone and wool, and all sorts of stuff. Okay. So we see that we're showing off an array. So whenever I see an array, I generally just like to get that array going instantly. So for int I equals 0. No, actually this one is different. This one is supposed to be for string items in an array. Let's see. Just gotta make sure I do everything the way I want to. So first we start with a switch, because we're doing switches, cases, breaks. Well, we don't actually using breaks.
Yeah.
And then we transfer it to sticks plus plus.
Okay, yeah. So you're using the fancy switch. That's what I'm gonna call it. Fancy switch with the arrows. Very cool. I mean, that's what I would use now that I know about it. So for each loop with a switch, and then you're going to increment variables that don't exist yet, but there's nothing wrong with writing something and then realizing you need a variable. So I assume that's what you'll do next.
With instance of 6, we'll add to 6 plus plus. We'll create our next case for wood. Fix that kind of errors with code, but it has to be plus plus. At this point, code's pretty much done. All that we do is we go down to return, we say math.min. This will turn out for every single time that stone occurs 2 times and skip. Instantiate our variables. So,
all right. Now you need variables.
Equals 0, wood equals 0, and stone equals 0. I actually really like creating the variables in one line.
Yep. Yeah, I mean that is actually really nice too. So that's the first time we've seen it in these videos. So those of you who are looking for ways to save on characters, you could do these all on different lines, saying int in front of each one. But if they're all ints, then you can combine them into a single initialization line.
While stone is greater or equal to 3, and sticks is greater or equal to 2, we need to go curly braces, we open it up. So while this happens, stone minus equals 3. Stick minus equals 2. And then x plus plus. So what this does is well, it says while stone is greater or equal to 3, and
yeah. I mean, that's pretty much perfect, except for a little bit of indentation inconsistency. And yeah, I like the loops that decrement out the ingredients. Just feels more like you're actually crafting something. The code sort of matches with how you think about the problem, or at least how I think about the problem. More so perhaps than the math-min division trick. Even though this is technically like a much shorter line, and it's also correct, for some reason I find the loop more intuitive.
We essentially clean our axes, but it's supposed to be sticks. I kind of mess around a little bit. See, everything works there. I'm leaving to
Yeah,
here.
yeah, you got it.
Because it's within the for loop. So everything that exists in here can be passed along. As long as the value is in here, everything's good. But we'll run the attempt.
Wait, you're doing your while loop inside your for loop. Oh. Yeah, I mean, I guess that works. It's like as you're getting ingredients, you're crafting Every time you get a new ingredient, you try to craft as many pickaxes as you can. It would also work on the outside, though. Is that how you had it before? Oh no, you had it inside the for loop from the beginning. So an example of how indentation can throw people off. So this switch doesn't quite line up with the while. And so in my brain, I was thinking the while was outside of the for loop. It's partly indentation and partly because that's what I expected, because that's how I would have done it and how I saw other people do it before. And then the indentation added the extra trick. I didn't even realize that was inside the for loop. It doesn't need to be, and it is a little bit... It's a little less efficient, because every time you process a new item, you have to run your pickaxe crafting code, when it would be fine to just do that at the end. Because there's going to be a lot of items... Well, okay, it's not that much less efficient. How about this? It's more complicated. The more you have stuff nested, when you don't need stuff to be nested, the more brain power it takes for other people to read your code and understand whether it's correct. So it's fine to do it this way, but I would pull it out. Maybe that's what you're about to do. Let's find out.
So, in the for loop, so everything that exists in here, was there anything else that I really missed? The first issue I kind of ran into here was
Oh, actually,
conditional array, but that really wasn't the case. Or I guess it was, but in a different way. Like, it was creating a variable called sticks, and it made it happen twice with the m. And it's the same thing with like the cobblestone. So it was just kind of an interesting thing, but it was really just a one-dimensional array.
yeah, they're using some fancy stuff to construct their tests. Some like mysterious im method, which I guess creates 2 sticks, and then make inventory like shoves it all into a single one-dimensional array. Yeah, so there's some magic stuff happening down here because they're trying to make their code, easy to read and maintain as well. Whoever wrote the tests, you can kind of see their style sticking through in some of the decisions that they made.
That was the first struggle, and from then it was figuring out, create switch use cases, and I could have done Wix, but I did that before. I wanted to show you, like this was my first time. And the first time,
Nice.
It just looked ugly. Like it worked, but it looked ugly. And then I started comparing it with other people's work, and
Yeah, great. Yeah, so that I actually appreciate you using extra minutes here, because you finished early, so using extra minutes to like talk about your process, awesome. Yeah, and yeah, you can see. I'll back it up here for other students who are watching. Yeah, you can see that the case break adds like an extra 2 lines per case statement, whereas here it's like a one-liner per case statement. So these are the kinds of things that you learned it one way, but there is another way, and you get to decide which one is the one you like the best. And generally speaking, you're gonna have aesthetic preferences, like if it could be on one line, put it on one line. It's a pretty good aesthetic rule. And so then you can decide you're going to start doing it this way instead of that way. Yeah, that is the Java learning process.
ugly. Like it worked, but it looked ugly. And then I started comparing it with other people's work, and I thought this just was so good. And I wanted to demonstrate like more than just do all this, return the math min. I wanted to actually say that it lets us to create axes. So way, which was a simple way, but maybe not exactly how it went. These are axes. But that's pretty much it.
Yeah, nice. That was great. That was a great one. All right, nice job. Okay, last video, number 15. This is a little quiet. I'll turn up the volume here.
No, we're just saying that this is declaring. We're not declaring story, because also a function. Is that line? Then I mentioned space builders, we're going to save again. Space builder.
Okay, hold on. You are programming in JavaScript, which is not the same as Java. Don't get me wrong, JavaScript is a fantastic language. I love JavaScript, and I, in fact, do most of my programming in JavaScript, not in Java these days. But they are very different languages in spite of the fact that they sound similar. So how about this? I'll make you a deal. This once, I won't take off points for JavaScript, but this is a Java class, so you gotta switch it for next week. It's cool that you're learning another language, and most of these problems do let you do it in multiple languages, but yeah, I'm gonna get in trouble if all I teach you this quarter is JavaScript. So please switch over to Java. But let's everyone watching, let's sit back and look at another language that can do all the same stuff as Java, just with a slightly different syntax. Oh, and then if you're like wondering, like, why do they have similar names? It was long ago just a marketing trick that when JavaScript was created, they wanted Java programmers to use it. And so they made the syntax like slightly, like kind of resembling Java a little bit. Like the for loops are similar. And then they called it JavaScript to just attract Java programmers to the language. And it's stuck ever since, even though JavaScript and Java are really vastly different languages, both syntactically and then also like under the hood semantically, they're different. If you want my preference, I actually prefer JavaScript, but that's just me. All right, let's do it.
Thanks. And then we're declaring an empty string, which will be called CSloader. And this array is much stored.
Okay, all right, so the array is coming in. First thing you notice about JavaScript, no type. What kind of type is that? Is array an array of strings? Is it an array of integers? Who knows? Like, JavaScript doesn't have type annotations the way Java does, so you're left kind of guessing. And that is maybe a plus about Java, is that you know more about what's coming in because it would say string array. But the syntax is cleaner when you construct a new array. So here's result equals new array. So this is exactly the same logic as we've seen in Java in several previous videos, creating a new array for the result, and we're creating a new string for concatenation. And in JavaScript, string concatenation is not so bad as it is in Java, I think. Well, let me just verify that before I tell you something wrong. Let's say JavaScript, do you need string builder? If you do, it's news to me, but let's see. Yes, JavaScript does not need a string builder. Yeah, so you use concatenation, and I think there are no drawbacks. Well, apparently there is in Internet Explorer, concatenation of strings is slow. But on modern browsers, plus equals is as fast as array joins. Okay, so that I'll continue to say what I said, which is in JavaScript, yeah, you can just initialize a string and then concatenate onto that string, and it's not slow the way it is in Java, just because of details under the hood and the way the JavaScript language was implemented versus the Java language. That's just a major difference. So don't need to worry about string builders in JavaScript. So that's maybe a plus of JavaScript. So comparing languages is almost impossible because it's just this giant list of pros and cons that goes on forever. I'll try to just call out some as we go.
That's it. Go on to the bubble loop the other side loop. These are the let I equals.
Okay. So notice it's let I equals, not int I equals. So that's because there's no types. So let's an int, or I is an int, so we say let. Space builder is a string, so we say let. Result is an array, so we say let. We never say what type it is, but there is some amount of inference that you can do. You can say, all right, what are they setting it equal to? Okay, therefore it must be an array. Setting it equal to a string, so therefore it must be a string. And an int here, of course. But the syntax is pretty similar. We still get the 2 semicolons, and these parts mean the same thing. So as a Java programmer, you should be able to read a for loop in JavaScript just fine.
So this is just the same loop. So start initialize start at 0. And then is there anything as long as array,
Okay. Yep. So we do concatenation. Syntax all exactly the same there. Result.push. Yep, that's how we get stuff onto an array. Oh yeah, another big difference is we don't in JavaScript need to say the length of an array. In Java, arrays are fixed length, so the moment you create it, you have to say this thing has 5 elements. And if you ever want the 6th element, you're going to have to create a new array that has 6 elements. But in JavaScript, you can create an empty array, length 0, and then whenever you want to, you can just stick stuff onto it. You never have to recreate. So JavaScript arrays are kind of nicer to work with than Java arrays. So you just do result.push, and we stick something on.
The space builder results. So we have here just a line Oh yeah, lines just add one more character just or progressively getting longer.
Okay, that should work. That looks right to me. Yeah, nice.
Right. Next one.
Nice. Okay.
Start off with if statements. Isolation equals 0.
Yep. And we see this looks pretty similar. Square root it, mod by 1, check to see if it's a whole number, return -1 if it's not.
Oh, and what is the object?
Otherwise,
Next.
next square is -1?
Closes. And all we did was paddle that initializes the variable to the integer. So
I'm not sure I understand. Oh,
so did a couple of times.
okay.
The source is always that just means the number multiplied by itself.
Oh, okay.
And then addition, where tab 2 list. This is checking if the next square is actually greater than the int list.
Okay, okay. So this is the solution where we... This is pretty fancy. Hold on. I'm gonna back up to see if you... Now that I understand where you're going with this, I want to see if you understood where you're going with this. Because what's going on with line 9? I think I know now. You're setting I to be the square root. And then you're going to loop over I and like increase it each time and check if it's the next square. And then that's why I guess you put -1 here, is eventually you'll find next square inside this loop and then you'll set next square. But this is a very sophisticated algorithm, so I want to know that you actually understand what you're writing here. So let me back up. All right, let's see. Let me listen to your narration here.
So what you do is do that and what is the object. So if it actually works. So in this case we call next square. Let's let the next number. Next thing, we're gonna take that, copy that, plug that in, close it. And all we did was paddle that initializes the variable to the I think just after the square root. What it also doing is searching for the next perfect square for the smallest integer. Because we're dealing with a true statement, not a false. So let's start with that.
Yeah, I don't know. I don't know if you like quite convinced me here. So yeah, we are taking the ceiling of the square root, but why? Like, the reason you're doing this depends on what you're about to do here. Like, why not start it at 0 and count up from 0? That would also work. Setting it to ceiling of square root is an optimization. But this to me kind of feels like you found a solution. I don't think you discovered this solution on your own. I think you found this somewhere and then are like, maybe you memorized it, maybe you understood parts of it, but I'm not convinced you understand the why of all parts of it. So I will probably take off some points here unless as it goes on it becomes clear that you understand. So yeah, that's the tricky thing here, is it's okay if you want to use somebody else's solution, but you need to understand all parts of it. And then you need to communicate that understanding to me. So I could be wrong. Feel free to send me a Canvas message if you feel like you really did understand it, but just didn't explain it well. But that's the sense I'm getting, is that there's some mysteries in the code here to you.
Let's write down conditions, and we'll say the current state that we're using. Yeah, I'm sorry. Yeah, that's one copy then. So I'll do a couple more times. Because these are perfect sources, always that just means it's going to be the number multiplied by itself. So let's say let's current square, or want to break that loop. That's what that word is. Yeah, but what do we want? But line being the next square. Next square. So we have the port that says it's -1, end it, and then we have the portion that says keep continuing on, find the perfect square, keep it up and up and up. But that doesn't satisfy, we break the function.
Okay, like that was good. I can tell you like understand the general idea of this. You know, we're going up and up and up until we find perfect square. I just think there are probably some details here that that are escaping you, and you might be able to explain it better, or you could just run your code and show me like why is it okay to start I at this value. I'll leave that as a mystery assignment to you or anyone who's watching. This is an interesting optimization, but out of scope for this class, so I won't talk about it just yet. All right, stone pickaxe. Let's see what you got here.
But I actually dove into the forums because I've actually learned something new about their last line, which is the return line, but we'll get to that soon. So first, we're going to initialize the line that are based on that. These are all starting from 0, so 0, cobblestone.
Oh, whoa. Okay, yeah, sorry. I forgot for a moment we're in JavaScript here. Yeah, so it's very hard for my brain to go back and forth. But yeah, so you are initializing a hash map, basically. Or in JavaScript, what would be called an object. So I talked about this earlier when it came up in one of the previous videos, but a hash map maps like a string, like sticks or cobblestones, to some other value, like a number. And in JavaScript, you can just define them. There's just a syntax for defining them. It's really kind of a nice syntax. In Java, you have to use hash map, and it's a little bit uglier. Everything in Java is a little bit more verbose than it would be in JavaScript. So those of you who like nice clean code, you may prefer JavaScript over Java. Perhaps Python over both of them. It's famously very clean in terms of its syntax.
That's wood. Well, there should be space there. Array for each material.
Okay, calling the array for each method.
Unique way of putting lines. I did this before in Java 1, but when looking into the forms of the Minecraft website, I've seen this time and time again. That's how materials are written down in their code. So material.
Yeah, okay. Yes. Yeah, this is okay. So this is how you do one way of doing a for each in JavaScript. This curly brace needs to start way earlier in the line. That'll help. I think you're also about to make another mistake. No, okay. Actually, it's fine. I see. So you're just looping over the materials and you're incrementing whichever value you end up seeing. So if it sticks, you add +1 sticks. All right. So logic is good.
By 1 is corresponding to the Ferrari cat. One.
If you're going to put your curly braces here, then this middle line needs to be farther in.
Wood is of wood.
Yep, okay. So you modify your sticks by your number of woods. That's good.
Stone pick requires.
And then this part should be almost exactly the same as Java. I'm going to do a min of the two divisions.
The map min function, which I've actually seen before, is just ensuring that functions.
Yeah, this line could be cleaned up a lot if you add additional variables. That would certainly help.
Or 2, so each material until it's satisfied. Yes. That initializes this. 6. For each material, that's correct.
Count is not defined.
This does look messy to me because it's new, but I think that's correct. Count sticks, counts wood, makes sense. Mat 4 counts sticks. Mat 4 counts cobblestone.
There you go. All right, you got it. All right.
All
All right. Nice job. Okay, I think that's the last video. I basically graded in one fell swoop all of the ones that were turned in on time. So if your video is in this batch, then that's why. And if your video is not in my video just now, then it's only because your assignment is late. I won't take off points for it, but as just kind of a reward for people who did get it in on time, I wanted to try to give some like quality feedback to to those of you who did. So nice job. All right, see you next time.